In the vast expanse of the cosmos, where darkness is punctuated by the fiery brilliance of stars, there lies a story older than time itself, a tale of creation, destruction, and rebirth. These celestial giants, born from the densest clouds of gas and dust, live lives that span millions, even billions of years, only to end in spectacular explosions that scatter their essence across the universe. This is the story of stars, the architects of the cosmos, and their journey from birth to demise. Today, we're peeling back the layers of the universe to uncover the secrets of stellar life cycles. From the glowing nurseries of nebulae to the cataclysmic end of supernova, we'll explore how stars shape the very fabric of existence. Get ready to witness the beauty, power, and mystery of the universe as we dive into the chronicles of stars, their beginnings, their endings, and their lasting impact on everything around them. Deep within the vast, swirling clouds of gas and dust scattered across the universe, the seeds of stars are sown. These regions, known as stellar nurseries, are cosmic cradles where the raw materials of the universe come together under the relentless pull of gravity. Picture a dense, dark molecular cloud, a place so thick with hydrogen, helium, and traces of heavier elements that light itself struggles to penetrate. Over millions of years, gravity works its magic, drawing these particles closer and closer until they collapse into dense knots of matter. At the heart of these knots, pressure and temperature soar, setting the stage for the birth of a star. One of the most famous stellar nurseries is the Orion Nebula, a glowing beacon in our night sky. Located about 1,300 light-years from Earth, it's a bustling hub of star formation, home to hundreds of young stars. The nebula's vibrant colors, shades of pink, red, and blue, come from the intense radiation of these newborn stars, illuminating the surrounding gas like a cosmic fireworks display. But the Orion Nebula is just one of countless such regions scattered throughout the universe, each playing a crucial role in the cycle of stellar life. Molecular clouds, the birthplaces of stars, are more than just chaotic collections of gas and dust. They are dynamic environments where gravity and turbulence collide, creating pockets of instability that trigger star formation. Within these clouds, filaments of gas stretch across light years, weaving intricate patterns that eventually fragment into smaller clumps. Each clump, if massive enough, will continue to collapse until nuclear fusion ignites at its core, marking the moment a star is truly born. This process, while beautiful, is also incredibly violent. The forces at play during a star's formation are immense, with temperatures reaching millions of degrees and pressures that defy imagination. Yet, from this chaos comes creation, a new star that will shine for millions or even billions of years, lighting up the darkness of space. As we marvel at these stellar nurseries, we can't help but wonder, what happens next in the life of a star? How does it grow, evolve, and ultimately meet its fate? The answers lie in the heart of the star itself, where the delicate balance of energy and gravity shapes its destiny. Once a star forms within the dense heart of a molecular cloud, the real magic begins, a process so powerful it lights up the cosmos. At the core of every star lies a fiery furnace where nuclear fusion takes place, the very engine that powers its radiant glow. This isn't just any reaction. It's the universe's way of transforming humble hydrogen into the building blocks of everything we know. Take our own sun, for example. Deep within its core, temperatures soar to an astonishing 15 million degrees Celsius. Under these extreme conditions, hydrogen atoms collide with such force that they overcome their natural repulsion and fuse together, creating helium. This fusion process releases an enormous amount of energy in the form of light and heat, which slowly makes its way to the surface and escapes into space. It's this energy that has warmed Earth for billions of years, making life as we know it possible. But what keeps a star like the Sun from collapsing under its own gravity or exploding outward from the sheer force of its energy? The answer lies in a delicate, almost cosmic balancing act. Gravity relentlessly pulls the star's material inward, compressing it and raising the core temperature even further. At the same time, the energy produced by fusion pushes outward, creating a counterforce that resists gravity's pull. This equilibrium between inward collapse and outward pressure is what keeps a star stable, allowing it to shine steadily for millions or even billions of years. It's fascinating to think that something as small as a hydrogen atom, the simplest and most abundant element in the universe, can fuel the brilliance of an entire star. Yet, this process isn't just about energy, it's about transformation. Every second, the Sun converts hundreds of millions of tons of hydrogen into helium, a process that has been ongoing for nearly 5 billion years. Over time, as the hydrogen supply in the core begins to dwindle, the star's balance shifts, setting the stage for the next chapter in its life. What happens when the fuel runs low? How does a star adapt, and what forces come into play as it evolves? These questions lead us to the next phase of a star's journey, where the balance of power shifts, and the star begins to change in ways that are both beautiful and catastrophic. The story of a star is far from over once fusion ignites. It's only just beginning. For billions of years, a star shines steadily, burning through its fuel with a consistency that defines its prime. This period, known as the main sequence, is the longest and most stable phase in a star's life. It's here, during these quiet yet radiant years, that stars like our Sun spend the bulk of their existence, balancing the forces of gravity and fusion in a cosmic dance that can last for eons. But not all stars are created equal. A star's mass is the ultimate dictator of its destiny. Smaller stars, like red dwarfs, are frugal with their fuel, burning slowly and steadily for trillions of years. These dim, cool stars may not shine as brightly as their larger counterparts, but their longevity is unmatched. On the other end of the spectrum, massive blue giants burn through their hydrogen reserves at a breakneck pace, shining with an intensity that can outshine entire galaxies, but only for a few million years. Our Sun, a middleweight in this cosmic lineup, sits comfortably in the middle with a lifespan of about 10 billion years. Stars are classified by their spectral types, a system that categorizes them based on temperature, color, and luminosity. The sequence ranging from O-type stars, the hottest and most luminous, to M-type stars, the coolest and dimmest, paints a vivid picture of stellar diversity. O-type stars, for instance, blaze with a blue-white light and are often found in the hearts of young star clusters, while M-type red dwarfs quietly glow in the background, their faint light barely detectable from afar. This classification isn't just a cosmic label, it's a window into a star's behavior, lifespan, and ultimate fate. The main sequence phase is more than just a star's golden years. It's a cornerstone of the universe's evolution. During this time, stars convert hydrogen into helium, releasing energy that powers not only their own brilliance, but also the chemical processes that shape their surroundings. Over billions of years, this steady fusion has enriched the cosmos with heavier elements, laying the groundwork for planets, moons, and even life itself. Yet, even the most stable stars cannot escape the passage of time. As hydrogen in the core begins to dwindle, the delicate balance between gravity and fusion starts to shift. For stars like our Sun, this marks the beginning of a new chapter, one where the star begins to age and evolve, stepping away from the main sequence and into a phase of transformation. What happens next depends on the star's mass, but one thing is certain: the prime years are only the beginning of a much larger story. As we peer into the night sky, filled with countless stars in various stages of their lives, we're reminded of the incredible diversity and dynamism of the universe. Each star, whether a humble red dwarf or a dazzling blue giant, plays a vital role in the cosmic tapestry. And as we continue to explore their lives, we uncover not just the secrets of the stars, but the story of everything that surrounds us. As the steady glow of a star's main sequence phase begins to wane, a profound transformation takes place deep within its core. For billions of years, stars like our Sun have burned hydrogen into helium, but this fuel is not infinite. When the hydrogen in the core is nearly exhausted, the star enters a new and dramatic chapter in its life, one marked by change, expansion, and the birth of heavier elements. The aging process of a star is a story of adaptation. Without enough hydrogen to sustain fusion, the core begins to contract under gravity's relentless pull. This compression heats the core even further, eventually reaching temperatures so high that helium, once a byproduct of hydrogen fusion, becomes the new fuel. Helium atoms fuse together to form carbon, releasing even more energy in the process. This shift marks the beginning of a star's evolution beyond the main sequence, a phase where its structure and appearance undergo dramatic changes. For stars like our Sun, this transition leads to the creation of a red giant. As helium fusion ignites in the core, the outer layers of the star expand outward, cooling and reddening as they grow. The once yellow star swells to hundreds of times its original size, its surface now a deep, glowing red. If our Sun were to reach this phase, it would engulf the inner planets, including Earth, in its vast, fiery embrace. Yet, this expansion isn't just about size. It's a sign of the star's struggle to balance its energy output with the forces of gravity. Massive stars, on the other hand, take this process to even greater extremes. Instead of becoming red giants, they evolve into red supergiants, colossal behemoths that dwarf even the largest of their smaller counterparts. Stars like Betelgeuse, a red supergiant in the constellation Orion, are so immense that if placed at the center of our solar system, their outer layers would extend beyond the orbit of Jupiter. These stars burn through their helium quickly, moving on to fuse even heavier elements like carbon, oxygen, and eventually silicon, creating a layered structure within their cores. This fusion of heavier elements is a testament to the star's resilience, but it comes at a cost. Each new fuel source burns faster and hotter than the last, accelerating the star's evolution and bringing it closer to its ultimate fate. The energy output fluctuates, causing the star to pulsate and shed its outer layers into space. These expelled materials, rich with newly formed elements, become part of the interstellar medium, seeding the cosmos with the ingredients for future stars, planets, and even life. Yet, even as a star ages and grows, its time is finite. The fusion of heavier elements is a race against time, a process that can only continue for so long before the star reaches its breaking point. For some stars, this leads to a quiet fading into the cosmos. For others, it sets the stage for one of the universe's most spectacular events, a cataclysmic explosion that will reshape its surroundings and leave an indelible mark on the galaxy. The aging process is just the prelude to the grand finale, a moment when the star's life reaches its climax and its legacy is written in the stars. As the final chapters of a low-mass star's life unfold, the universe reveals a side of stellar death that is both serene and profoundly beautiful. Unlike their massive counterparts, which meet their end in fiery explosions, stars like our Sun and smaller red dwarfs experience a more tranquil farewell, one that leaves behind a shimmering legacy in the form of planetary nebulae and white dwarfs. When a Sun-like star exhausts its helium fuel, its core contracts into a dense, Earth-sized remnant, while its outer layers expand and drift away into space. This expelled material forms a luminous shell of gas and dust, illuminated by the intense ultraviolet light of the exposed core. These glowing clouds, known as planetary nebulae, are some of the most stunning sights in the cosmos. The Helix Nebula, for example, with its intricate rings and vibrant hues, resembles a cosmic eye gazing out into the void, a testament to the star's final act of creation. At the heart of these nebulae lies the star's core, now a white dwarf. Although no longer undergoing fusion, a white dwarf is still incredibly hot, radiating leftover heat from its earlier life. Over billions of years, it will slowly cool and fade, eventually becoming a cold, dark object known as a black dwarf. Yet, even in its quiet decline, a white dwarf plays a crucial role in the cosmic cycle. The material it sheds enriches the surrounding space with elements forged during its lifetime, providing the raw materials for future generations of stars and planets. Red dwarfs, the smallest and most abundant stars in the universe, follow a similar path but on a vastly longer timescale. These stars burn their fuel so slowly that some are destined to outlive the universe itself. When they finally exhaust their hydrogen, they too will shed their outer layers, leaving behind a white dwarf. However, their quiet, prolonged existence ensures that they remain a constant presence in the cosmos, silently shaping its evolution over eons. This peaceful end stands in stark contrast to the explosive deaths of massive stars, which we'll explore next. While low-mass stars fade gently into the cosmic background, their larger counterparts go out in a blaze of glory, leaving behind remnants that are just as fascinating but far more dramatic. The universe, it seems, has a way of balancing the serene with the spectacular, ensuring that every star's story is as unique as the light it casts across the cosmos. When the most massive stars in the universe reach the end of their lives, they don't fade quietly into the night. Instead, they go out with a bang, a cosmic explosion so powerful it can outshine entire galaxies. This spectacular end is known as a supernova, and it's one of the most awe-inspiring events in the cosmos. The journey to a supernova begins deep within the star's core. After billions of years of fusing lighter elements like hydrogen and helium, a massive star exhausts its fuel and begins to fuse heavier elements carbon, oxygen, even silicon. But this process can only continue for so long. Once the star's core starts producing iron, a critical turning point is reached. Unlike the elements before it, iron cannot be fused to release energy. Instead, it acts like a cosmic sponge, absorbing energy and destabilizing the core. What happens next is nothing short of cataclysmic. The core, no longer able to support its own weight, collapses in on itself in a fraction of a second. This collapse generates an intense shockwave that rips through the star's outer layers, blasting them into space at incredible speeds. The resulting explosion is so bright it can be seen across billions of light years, a fleeting but brilliant beacon in the darkness. Supernovae are more than just cosmic fireworks, they're the universe's great recyclers. During the explosion, the intense heat and pressure forge elements heavier than iron, such as gold, silver, and uranium. These newly formed elements, along with the star's outer layers, are hurled into space, scattering across the cosmos. Over time, they become part of interstellar clouds, the raw materials for new stars, planets, and even life itself. Without supernova, the universe would lack many of the elements that make up the world around us. But the story doesn't end with the explosion. What remains after a supernova is just as fascinating as the event itself. Depending on the star's original mass, the core may collapse into a neutron star, an incredibly dense object where a teaspoon of material would weigh billions of tons, or in the case of the most massive stars, a black hole, a region of space where gravity is so strong that not even light can escape. These remnants, born from the ashes of a supernova, continue to shape the cosmos in profound ways. The death of a massive star is a reminder of the universe's incredible power and beauty. It's a process that transforms destruction into creation, scattering the seeds of new beginnings across the void. As we look up at the night sky, we're witnessing not just the light of stars, but the echoes of their explosive ends, a testament to the ever-changing, ever-evolving nature of the cosmos. After the fiery brilliance of a supernova fades, what remains is often one of the most bizarre and fascinating objects in the universe, a neutron star. These cosmic remnants, born from the collapsed cores of massive stars, are so dense that a single teaspoon of their material would weigh billions of tons. Imagine compressing the mass of the sun into a sphere no wider than a city. That's the mind-bending reality of a neutron star, where matter is squeezed to its absolute limits. Neutron stars owe their existence to the extreme conditions of a supernova. When a massive star's core collapses, protons and electrons are crushed together, forming neutrons. The result is a star made almost entirely of these subatomic particles, packed so tightly that the laws of physics, as we know them, are pushed to their breaking point. The surface of a neutron star is a solid crust, but beneath it lies a sea of superfluid neutrons, a state of matter so exotic it defies earthly comparison. One of the most striking features of neutron stars is their rapid rotation. As the core of a massive star collapses, its rotation speeds up dramatically, much like a figure skater pulling in their arms during a spin. Some neutron stars spin hundreds of times per second, their surfaces whipping around at incredible speeds. This rapid rotation, combined with intense magnetic fields billions of times stronger than Earth's, gives rise to some of the most energetic phenomena in the cosmos. Take pulsars, for example. These are neutron stars that emit beams of radiation from their magnetic poles. As the star spins, these beams sweep across the sky like a cosmic lighthouse. If Earth happens to lie in the path of these beams, we detect regular pulses of radiation, sometimes flashing dozens or even hundreds of times per second. The first pulsar discovered, named LGM-1, was initially mistaken for a signal from extraterrestrial life, a testament to how strange and otherworldly these objects truly are. Then there are magnetars, neutron stars with magnetic fields so powerful they can distort the structure of atoms and generate starquakes, violent tremors that release bursts of gamma rays. These bursts, some of the most energetic events in the universe, can be detected across vast distances, lighting up the cosmos like a cosmic flare. Magnetars are rare and short-lived, their intense magnetic fields decaying over time, but while they exist, they are among the most dynamic and unpredictable objects in space. Neutron stars are more than just relics of stellar death. they are laboratories for studying the extremes of physics. Their incredible density, rapid rotation, and intense magnetic fields challenge our understanding of matter, gravity, and the fundamental forces of nature. Yet, even among these extraordinary objects, there exists something even more mysterious, a remnant so dense, so powerful, that not even light can escape its grasp. This is the realm of black holes, where the laws of physics as we know them cease to apply, and the universe reveals its deepest secrets. In the aftermath of a supernova, when the dust begins to settle and the light fades, some stars leave behind something far more enigmatic than a neutron star, a black hole. These cosmic phenomena are the ultimate expression of gravity's power, regions of space where the pull is so intense that not even light can escape. Born from the collapse of the most massive stars, black holes are more than just remnants. They are gateways to understanding the universe's deepest mysteries. The formation of a stellar black hole begins much like that of a neutron star. When a star many times more massive than our Sun exhausts its nuclear fuel, its core collapses under its own gravity. But for the most massive stars, this collapse doesn't stop at forming neutrons. Instead, the core continues to compress until it reaches a point of infinite density known as a singularity. Surrounding this singularity is the event horizon, a boundary beyond which nothing, not even light, can escape. This is the defining feature of a black hole, the point of no return where the laws of physics as we know them begin to break down. What makes black holes so fascinating is their ability to warp spacetime itself. According to Einstein's theory of general relativity, massive objects like stars and planets create curves in the fabric of spacetime, which we experience as gravity. But a black hole takes this to an extreme. Its immense mass creates such a deep well in spacetime that anything crossing the event horizon is forever trapped. This distortion isn't just theoretical, it has real, observable effects. Light passing near a black hole bends around it, a phenomenon known as gravitational lensing, while time itself slows down in its presence. Despite their reputation as cosmic vacuum cleaners, black holes aren't just destructive forces. They play a crucial role in shaping the universe. Stellar black holes, formed from the collapse of massive stars, are scattered throughout galaxies, influencing the motion of nearby stars and gas. Some even grow by consuming matter from their surroundings, releasing vast amounts of energy in the process. This energy can heat up surrounding gas, triggering the formation of new stars or even entire galaxies. In a way, black holes are both creators and destroyers, weaving themselves into the fabric of cosmic evolution. But the story of black holes doesn't end with stellar remnants. At the centers of most galaxies, including our own Milky Way, lie supermassive black holes, behemoths millions or even billions of times more massive than the Sun. These giants didn't form from a single star's collapse but grew over time, merging with other black holes and devouring vast amounts of matter. Their presence is felt across cosmic scales, shaping the structure of galaxies and driving some of the most energetic events in the universe. Black holes challenge our understanding of the cosmos, pushing the boundaries of physics and forcing us to rethink our assumptions about space, time, and reality itself. They are reminders of the universe's capacity for both creation and destruction, a duality that defines the very nature of existence. As we continue to explore these enigmatic objects, we uncover not just the secrets of black holes, but the story of the universe itself, one where the darkest corners hold the brightest insights. At the heart of nearly every galaxy, including our own Milky Way, lies a cosmic heavyweight that defies imagination, a supermassive black hole. These colossal entities, millions or even billions of times more massive than the Sun, are not just passive observers of galactic life. They are active architects, shaping the very structure and evolution of the galaxies they inhabit. Their influence extends far beyond their event horizons, weaving themselves into the fabric of cosmic history. Supermassive black holes are thought to form through a combination of processes, including the merging of smaller black holes and the rapid accumulation of gas and dust over billions of years. Over time, their immense gravitational pull draws in surrounding matter, creating swirling disks of superheated material known as accretion disks. These disks glow with intense radiation, often outshining all the stars in their host galaxies combined. This phenomenon, known as an active galactic nucleus, is one of the most energetic processes in the universe. But the role of supermassive black holes goes far beyond just consuming matter. They are cosmic regulators, influencing the birth and death of stars throughout their galaxies. When a black hole feeds, it doesn't just swallow everything in its path. Some of the material is ejected outward in powerful jets of particles and radiation, traveling at nearly the speed of light. These jets can heat up the surrounding gas, preventing it from cooling and collapsing into new stars. In this way, supermassive black holes act as a kind of cosmic thermostat, controlling the rate of star formation and maintaining a delicate balance within their galaxies. Take the Milky Way's own supermassive black hole, Sagittarius A. While it's relatively quiet today, there's evidence that it was once far more active, with outbursts that shaped the evolution of our galaxy. Even now, its gravitational influence keeps the stars in the galactic center orbiting at incredible speeds, creating a dynamic and tightly packed region of space. Without this central anchor, the Milky Way, as we know it, might look very different. The relationship between supermassive black holes and their galaxies is a two-way street. Just as black holes influence star formation and galactic structure, the galaxies themselves play a role in feeding and growing their central black holes. This symbiotic connection is a key driver of galactic evolution, shaping the diversity of galaxies we see today, from spiral galaxies like our own to the massive elliptical galaxies found in galaxy clusters. As we peer deeper into the cosmos, we're beginning to understand that black holes are not just isolated oddities. They are integral to the story of the universe, playing a central role in the formation and evolution of galaxies. From regulating star formation to powering some of the most energetic phenomena in the universe, black holes are cosmic forces that shape the very fabric of existence. And as we continue to explore their mysteries, we uncover not just the secrets of these enigmatic objects, but the story of how the universe itself came to be. This intricate dance between black holes and galaxies is just one piece of the larger cosmic puzzle, a puzzle that reminds us of the interconnectedness of all things, from the tiniest particles to the grandest structures in the universe. As we look to the stars, we're not just observing distant objects, we're witnessing the ongoing story of creation, destruction, and rebirth that defines the cosmos itself. Among the countless stars scattered across the cosmos, many don't journey alone. Instead, they dance in pairs, locked in a gravitational embrace that shapes their lives and destinies. These are binary star systems, pairs of stars orbiting a common center of mass. While single stars like our Sun dominate the night sky, binary systems make up a significant portion of the stellar population, offering a unique window into the complexities of stellar evolution and the universe's most dramatic phenomena. In a binary system, the two stars can range from nearly identical twins to vastly different companions. Some are so close they almost touch, while others orbit at great distances, their connection maintained by gravity's invisible threads. The interplay between these stars can lead to extraordinary events. For instance, when one star in a close binary system expands into a red giant, it can transfer material to its companion, creating a swirling disk of gas that fuels intense bursts of energy. In some cases, this process can trigger a nova, a sudden, dramatic increase in brightness as the accumulated material ignites in a thermonuclear explosion. But the drama doesn't stop there. In more extreme systems, one of the stars may collapse into a dense remnant like a neutron star or black hole. If its companion continues to feed it material, the result can be an X-ray binary, a system that emits powerful X-rays as the material spirals into the dense object, heating up to millions of degrees. These systems are cosmic laboratories, allowing scientists to study the behavior of matter under extreme conditions that would be impossible to replicate on Earth. Perhaps the most spectacular outcome of binary systems occurs when both stars are massive enough to end their lives as black holes or neutron stars. Over time, their orbits decay, drawing them closer together until they collide in a cataclysmic merger. These events send ripples through space-time, known as gravitational waves, which can be detected by observatories like LIGO and Virgo. The detection of such mergers has opened a new era in astronomy, providing insights into the nature of gravity, the formation of black holes, and the origins of heavy elements like gold and platinum. Binary star systems are more than just cosmic curiosities. They play a crucial role in our understanding of stellar evolution. By studying how these pairs interact, astronomers can learn about the processes that drive star formation, the transfer of mass between stars, and the ultimate fate of stellar remnants. They also serve as natural laboratories for testing theories about gravity, relativity, and the behavior of matter under extreme conditions. As we shift our gaze from individual stars to the larger structures they form, we find another fascinating aspect of the cosmos star clusters. These dense collections of stars, bound together by gravity, are the next chapter in our exploration of the universe's stellar tapestry. Whether they are open clusters with a few hundred loosely bound stars or globular clusters containing hundreds of thousands of ancient stars, these gatherings offer a glimpse into the communal life of stars and the intricate dance of gravity that binds them together. Scattered across the night sky, like jewels strewn across velvet, star clusters are some of the most captivating sights in the universe. These gatherings of stars, bound together by gravity, are cosmic communities that tell stories of birth, evolution, and the passage of time. Whether they are the loose, sparkling groups of open clusters or the densely packed spheres of globular clusters, these stellar gatherings offer a unique glimpse into the lives of stars and the history of the cosmos itself. Star clusters form in the heart of vast molecular clouds, where pockets of gas and dust collapse under gravity's pull. Open clusters, such as the famous Pleiades, are relatively young, containing anywhere from a few dozen to a few thousand stars. These stars are often siblings, born from the same cloud of material, and they share a common origin. The Pleiades, also known as the Seven Sisters, is a stunning example. Located about 440 light-years from Earth, this cluster is easily visible to the naked eye, its bright blue stars glowing against the backdrop of space. Open clusters are dynamic and short-lived by cosmic standards, their stars gradually drifting apart over millions of years as they are influenced by the gravitational pull of other objects in the galaxy. In contrast, Globular clusters are ancient relics containing hundreds of thousands of stars packed into a tight, spherical shape. These clusters are among the oldest objects in the universe, with some dating back nearly as far as the Big Bang itself. Omega Centauri, one of the largest and most famous globular clusters, contains millions of stars and shines brightly in the southern sky. Unlike open clusters, globular clusters are incredibly stable, their stars held together by a strong gravitational bond that has endured for billions of years. The stars in these clusters are often old and metal-poor, offering a window into the early universe and the conditions that existed when the first stars formed. Star clusters are more than just beautiful celestial objects, they are cosmic laboratories. By studying the stars within them, astronomers can piece together the history of stellar evolution. Open clusters, for example, provide insights into how stars form and disperse, while globular clusters reveal the long-term dynamics of stellar populations. The chemical composition of stars in these clusters also tells us about the enrichment of the universe over time, as successive generations of stars forged heavier elements and scattered them into space. Beyond their scientific value, star clusters play a vital role in shaping their surroundings. The intense radiation from young stars in open clusters can ionize nearby gas, creating glowing nebulae that light up the cosmos. Globular clusters, with their immense gravitational pull, can influence the structure of their host galaxies, acting as anchors in the vast sea of stars. These clusters are not just passive observers, they are active participants in the cosmic dance, shaping the environment around them in ways that ripple across the universe. As we gaze at the stars, we're reminded that they are rarely alone. Whether gathered in sparkling open clusters or tightly bound globular clusters, stars are part of a larger community, their lives intertwined in a cosmic story that spans billions of years. And as we continue to explore these stellar gatherings, we uncover not just the secrets of the stars, but the history of the universe itself, a story written in light, gravity, and the passage of time. This interconnectedness of stars leads us to the next chapter of our journey, the role of stars in shaping the galaxies they inhabit. From the birth of stars in dense molecular clouds to their influence on the structure and evolution of galaxies, the story of stars is deeply woven into the fabric of the cosmos. And as we turn our gaze to the larger structures they form, we begin to see just how profoundly stars shape the universe around them. As stars burn brightly in the vast expanse of space, they don't just sit quietly in the cosmic void. They actively shape their surroundings in ways that are both subtle and profound. One of the most powerful tools in their arsenal is something called stellar winds. These are streams of charged particles, flowing outward from a star's surface at incredible speeds, carrying energy and material into the surrounding space. For massive stars, these winds can be particularly fierce, reaching velocities of millions of kilometers per hour and sweeping up everything in their path. Imagine a star like Eta Carinae, one of the most massive and luminous stars known. Its stellar winds are so intense that they carve out vast cavities in the surrounding gas and dust, creating complex structures that resemble cosmic sculptures. These winds don't just blow aimlessly, they interact with the interstellar medium, the thin soup of gas and dust that fills the space between stars. As these winds collide with the surrounding material, they compress it, triggering the formation of new stars in nearby regions. In this way, stellar winds act as cosmic sculptors, shaping the landscape of star-forming regions and influencing the birth of future generations of stars. But the impact of stellar winds goes beyond just shaping their immediate surroundings. Over time, these winds can strip away a star's outer layers, exposing its core and altering its evolution. For massive stars, this process can be dramatic, as the winds carry away vast amounts of material, sometimes even more than the star itself will eventually lose in a supernova explosion. This material, rich in heavy elements forged in the star's core, becomes part of the interstellar medium, seeding the cosmos with the building blocks for planets, life, and even other stars. One of the most stunning examples of stellar winds at work can be seen in the creation of nebulae. The famous Crab Nebula, for instance, owes its intricate structure in part to the powerful winds emitted by the star at its center before it exploded as a supernova. These winds carved out the nebula's delicate filaments and shock waves, leaving behind a breathtaking tapestry of light and gas. Similarly, the Veil Nebula, with its wispy, thread-like features, is a testament to the enduring influence of stellar winds, even long after the star itself has faded from view. As we explore the impact of stellar winds, we begin to see how stars are not just isolated points of light, but active participants in the cosmic dance. They shape their environments, influence the birth of new stars, and leave behind a legacy that endures long after they're gone. And when a massive star's life comes to an end, its final act, a supernova explosion, builds on this legacy, creating remnants that continue to shape the universe in ways that are both beautiful and profound. This transition from stellar winds to supernova remnants marks the next chapter in our journey through the lives of stars, a story of creation, destruction, and the enduring impact of these celestial giants on the cosmos. As we delve deeper, we'll uncover how the remnants of supernova, the echoes of stellar explosions, continue to influence the universe, shaping the very fabric of space and time. As the echoes of a supernova explosion fade, what remains is not just a void, but a vibrant testament to the star's final act, a supernova remnant. These remnants are the cosmic fingerprints of stellar destruction, expanding clouds of gas and dust that carry the story of the star's life and death across the universe. Among the most famous is the Crab Nebula, a glowing tapestry of light and energy that serves as a vivid reminder of the power and beauty of stellar explosions. When a massive star explodes as a supernova, it doesn't just vanish into the void. Instead, it leaves behind a rapidly expanding shell of material, hurtling outward at thousands of kilometers per second. This material, enriched with heavy elements forged in the star's core, becomes part of the interstellar medium, the vast reservoir of gas and dust that fills the space between stars. Over time, these remnants grow, their intricate filaments and shockwaves creating stunning patterns that can span dozens of light years. The Crab Nebula, for instance, is the result of a supernova observed on Earth in the year 1054. Today, it spans about 11 light years, its swirling colors a testament to the elements it has scattered into space. But supernova remnants are more than just cosmic artwork, they are engines of creation. As these expanding clouds collide with the surrounding interstellar medium, they compress the gas and dust, triggering the formation of new stars. In this way, the death of one star becomes the birth of many others, a cycle that has repeated countless times throughout the history of the universe. The heavy elements forged in the star's core, carbon, oxygen, iron, and even gold, are now scattered across the cosmos, becoming the building blocks for planets, moons, and even life itself. The role of supernova remnants in enriching the universe cannot be overstated. Without these explosions, the cosmos would lack many of the elements essential for the formation of complex structures. The iron in our blood, the calcium in our bones, and the silicon in the Earth's crust were all forged in the hearts of massive stars and scattered by their explosive deaths. Supernova remnants are not just the end of a star's life, they are the beginning of something new, a bridge between the old and the new, the past and the future. As we observe these remnants, we're reminded of the interconnectedness of the cosmos. The death of a star is not an isolated event, but a crucial step in the cosmic cycle, a process that has shaped the universe as we know it. From the birth of stars in dense molecular clouds to their explosive deaths and the creation of new stars from their remains, the story of stars is one of constant renewal and transformation. And as we continue to explore these remnants, we uncover not just the secrets of stellar evolution, but the story of how the universe itself came to be, a story written in light, energy, and the enduring legacy of stars. This intricate dance of creation and destruction leads us to the next chapter of our journey, the role of stars in shaping the galaxies they inhabit. From the birth of stars in dense molecular clouds to their influence on the structure and evolution of galaxies, the story of stars is deeply woven into the fabric of the cosmos. And as we turn our gaze to the larger structures they form, we begin to see just how profoundly stars shape the universe around them. The death of a star is not an end, but a beginning, a cosmic recycling process that transforms destruction into creation. When a massive star explodes in a supernova, it doesn't just vanish into the void. Instead, it scatters its remains across the cosmos, enriching the interstellar medium with a wealth of heavy elements. This interstellar medium, the vast sea of gas and dust that fills the space between stars, becomes the raw material for the next generation of stars, planets, and even life itself. The interstellar medium is more than just empty space, it's a dynamic, ever-changing reservoir of cosmic ingredients, composed mostly of hydrogen and helium, with traces of heavier elements like carbon, oxygen, and iron. It's the birthplace of stars and the canvas on which the universe paints its grandest structures. When a star dies, it injects this medium with newly forged elements, creating a richer, more complex environment for future star formation. This cycle of stellar death and rebirth is a cornerstone of the universe's chemical evolution. Every supernova explosion, every planetary nebula, and even the gentle winds of aging stars contribute to this process, gradually increasing the concentration of heavy elements in the cosmos. Over billions of years, these elements have become the building blocks for planets, moons, and the complex molecules that make life possible. The iron in your blood, the calcium in your bones, and the silicon in the Earth's crust. All of these were forged in the hearts of stars and scattered by their explosive deaths. The importance of heavy elements cannot be overstated. Without them, the universe would be a far simpler place, populated only by hydrogen and helium. Planets like Earth, with their diverse geology and rich chemistry, would not exist. Life, as we know it, would be impossible. The carbon, nitrogen, and oxygen that form the basis of organic molecules are all products of stellar nucleosynthesis, the process by which stars create and distribute these elements. This cosmic recycling process is a testament to the interconnectedness of the universe. The death of one star becomes the birth of countless others, each generation building on the legacy of those that came before. As stars form from the enriched interstellar medium, they continue the cycle, burning hydrogen and helium to create even heavier elements. Over time, this process has transformed the universe from a sea of simple elements into a rich tapestry of complexity, filled with galaxies, stars, planets, and life. The role of stars in the universe's chemical evolution is profound. They are not just sources of light and energy, they are the engines of creation, driving the transformation of the cosmos from simplicity to complexity. As we look out at the night sky, we're witnessing not just the light of distant stars, but the ongoing story of the universe's growth and change, a story written in the language of chemistry, gravity, and time. This journey from stellar death to new life brings us to the next chapter of our exploration, the role of stars in shaping the galaxies they inhabit. From the birth of stars in dense molecular clouds to their influence on the structure and evolution of galaxies, the story of stars is deeply woven into the fabric of the cosmos. And as we turn our gaze to the larger structures they form, we begin to see just how profoundly stars shape the universe around them. The story of the universe isn't just written in light and gravity, it's also written in the language of chemistry. Over billions of years, stars have acted as cosmic alchemists, transforming the simplest elements into the building blocks of everything we see around us. This process, known as nucleosynthesis, is the key to understanding how the universe evolved from a sea of hydrogen and helium into the rich, complex tapestry it is today. At the heart of every star, from the smallest red dwarf to the most massive blue giant, lies a nuclear furnace. Here, hydrogen atoms fuse together to form helium, releasing energy in the process. But this is just the beginning. As stars age and exhaust their hydrogen fuel, they begin fusing heavier elements, carbon, oxygen, and eventually even iron. Each step in this process requires higher temperatures and pressures, pushing the star to its limits. In the most massive stars, this chain of fusion reactions continues until the core is filled with iron, an element that cannot be fused to release energy. This marks the beginning of the end, as the star prepares for its final, explosive act. The true magic of nucleosynthesis, however, happens in the moments after a supernova explosion. When a massive star collapses and then explodes, the intense heat and pressure create conditions that allow the formation of even heavier elements: gold, silver, uranium, and more. These elements, forged in the heart of a dying star, are scattered into space by the force of the explosion, becoming part of the interstellar medium. Over time, this enriched material mixes with the surrounding gas and dust, providing the raw ingredients for new stars, planets, and even life itself. What's truly remarkable is how this process has shaped the chemical composition of the cosmos. In the early universe, shortly after the Big Bang, only the lightest elements, hydrogen, helium, and trace amounts of lithium, existed. But as generations of stars lived, died, and exploded, they seeded the universe with heavier elements, gradually increasing its chemical complexity. Today, when we look at the periodic table, we're not just seeing a list of elements, we're seeing the legacy of countless stars and their explosive deaths. This ongoing cycle of creation and destruction has given rise to what astronomers call stellar populations, groups of stars that share similar ages, compositions, and origins. The oldest stars, known as population Roman II stars, are relics of the early universe. They are metal-poor, meaning they contain very few elements heavier than hydrogen and helium. These ancient stars provide a window into the universe's infancy, a time when it was far simpler and less chemically diverse. In contrast, younger stars like our Sun, classified as population I stars, are rich in heavy elements, a testament to the generations of stars that came before them. These stars, born from the enriched interstellar medium, are the products of billions of years of cosmic evolution. Their abundance of heavy elements not only makes them chemically complex, but also increases the likelihood of forming planets and potentially life. As we explore the chemical evolution of the universe, we begin to see how stars are more than just sources of light. They are the architects of the cosmos, shaping its composition and driving its transformation over time. From the first stars that illuminated the darkness to the supernova that scattered the seeds of life, every star plays a role in this grand cosmic story. And as we turn our gaze to the stars above, we're reminded that the elements within us, the iron in our blood, the calcium in our bones, were forged in the hearts of stars, connecting us to the universe in the most profound way imaginable. As we journey deeper into the cosmos, we uncover a fascinating way to trace the universe's history, not through ancient artifacts or forgotten texts, but through the stars themselves. Just as archaeologists study layers of sediment to understand Earth's past, astronomers classify stars into distinct groups called stellar populations. These groups, based on age and chemical composition, act as cosmic time capsules, revealing the story of how the universe has evolved over billions of years. The oldest stars, known as population Roman II stars, are relics of a time when the universe was young and unspoiled. Born from the primordial gas left over from the Big Bang, these stars are metal-poor, meaning they contain very few elements heavier than hydrogen and helium. They are the cosmic equivalents of ancient ruins, offering glimpses into an era when the universe was simpler, darker, and less chemically diverse. Found primarily in globular clusters and the halos of galaxies, population Roman II stars are like living fossils, preserving the conditions of the early cosmos in their faint, enduring light. In contrast, younger stars like our Sun belong to population I. These stars are rich in heavy elements, such as carbon, oxygen, and iron elements forged in the hearts of earlier stars and scattered across the universe by supernova. Population I stars are the products of a chemically enriched universe, one that has been shaped and reshaped by generations of stellar life and death. They are often found in the spiral arms of galaxies, where active star formation continues to this day. The presence of these elements not only makes population I stars chemically complex, but also increases the likelihood of planets forming around them, planets like Earth, where the building blocks of life are abundant. But what about the very first stars, the ones that ignited in the darkness of the early universe? These stars, known as population Roman III, are thought to have been massive, short-lived, and composed almost entirely of hydrogen and helium. While no population Roman III stars have been observed directly, they likely burned out billions of years ago. Their existence is inferred from the chemical signatures they left behind. These stars were the pioneers of cosmic chemistry, the first to fuse hydrogen into helium, and in their explosive deaths, to scatter heavier elements into the void. Their legacy lives on in the stars and galaxies that followed, a testament to their role in lighting up the cosmos and setting the stage for everything that came after. Stellar populations are more than just a way to classify stars, they are a roadmap to understanding the universe's history. By studying these groups, we can piece together how the cosmos evolved from a sea of simple elements into the rich, complex tapestry it is today. Population Roman II stars remind us of the universe's humble beginnings, while population I stars reflect its ongoing transformation. And though population Roman III stars remain elusive, their influence is undeniable, woven into the very fabric of the cosmos. As we continue to explore the stars, we're not just observing distant objects, we're uncovering the story of the universe itself, written in the language of light, chemistry, and time. Each star, whether ancient or young, is a chapter in this grand narrative, a reminder of the interconnectedness of all things in the cosmos. And as we turn our gaze to the larger structures they form, we begin to see just how profoundly stars shape the universe around them, from the smallest particles to the grandest galaxies. Long before galaxies spiraled into existence and planets formed around younger stars, the universe was a dark, empty void, a canvas waiting for its first brushstroke of light. That light came from the very first stars, a generation astronomers call population Roman 3. These ancient giants, born from the purest ingredients of the cosmos, hydrogen and helium, were unlike anything we see today. They were the pioneers of the universe, the ones who ignited the darkness and set the stage for everything that followed. Population Roman 3 stars formed in the early universe, just a few 100 million years after the Big Bang. At that time, the cosmos was a simpler place, lacking the heavy elements we now take for granted. Without elements like carbon, oxygen, or iron, these stars were composed almost entirely of hydrogen and helium, the raw materials left over from the Big Bang itself. This purity made them fundamentally different from the stars we see today, not just in composition, but in size and behavior. Imagine stars so massive they dwarf even the largest blue giants we know. Population Roman 3 stars were thought to be hundreds of times more massive than our Sun, blazing with an intensity that's almost unimaginable. Their lives were brief but brilliant, burning through their fuel in just a few million years before ending in spectacular supernova. These explosions were more than just cosmic fireworks, they were transformative events, scattering the first heavy elements into the universe and lighting up the cosmos in a process known as reionization. Reionization was a pivotal moment in the universe's history. Before the first stars, the cosmos was filled with neutral hydrogen gas, absorbing light and keeping the universe dark. But the intense radiation from population Roman 3 stars stripped electrons from these hydrogen atoms, ionizing the gas and allowing light to travel freely through space. This process, which unfolded over hundreds of millions of years, marked the end of the cosmic dark ages and the dawn of the universe as we know it. The legacy of population Roman 3 stars is written in the stars and galaxies that followed. Their explosive deaths seeded the cosmos with the first heavy elements, creating the building blocks for future stars, planets, and even life. While no population Roman 3 stars have been observed directly, they likely burned out billions of years ago. Their fingerprints can still be found in the oldest stars and the most distant galaxies. These ancient giants may be gone, but their impact echoes across the universe, a testament to their role in shaping the cosmos. As we explore the mysteries of the first stars, we're reminded of how far the universe has come. From the darkness of the early cosmos to the vibrant, complex tapestry we see today, every step in this journey has been shaped by the stars that came before. And as we peer deeper into the night sky, we're not just looking at stars, we're uncovering the story of how the universe itself came to be, one brilliant light at a time. This journey from the first stars to the galaxies they helped create brings us to the next chapter of our exploration, the birth of galaxies in the early universe, and how the legacy of population Roman 3 stars continues to shape the cosmos on the grandest scales. The death of population Roman 3 stars wasn't just an end, it was a cosmic turning point, a moment that ignited the universe's transformation from simplicity to complexity. These ancient giants, though short-lived, left behind a legacy that shaped everything we see today. When they exploded as supernova, they scattered the first heavy elements carbon, oxygen, and nitrogen into the void, enriching the pristine hydrogen and helium of the early universe. This material became the building blocks for the next generation of stars, seeding the cosmos with the ingredients needed for planets, galaxies, and even life itself. These second-generation stars, born from the ashes of their predecessors, were fundamentally different. Unlike the pure hydrogen and helium of population Roman 3 stars, they contained traces of heavier elements, which allowed them to form more efficiently and burn cooler and longer. This shift marked the beginning of a new era, one where stars could form in greater numbers and with greater diversity. Over time, these stars coalesced into the first galaxies, creating the vibrant cosmic tapestry we observe today. But the influence of population Roman 3 stars didn't stop there. Their explosive deaths also played a crucial role in reionizing the universe, stripping electrons from hydrogen atoms and allowing light to travel freely through space. This process, which unfolded over hundreds of millions of years, transformed the cosmos from a dark, opaque void into a luminous, transparent expanse. It was a pivotal moment in the universe's history, one that set the stage for the formation of galaxies and the emergence of complex structures. As we trace the legacy of population Roman 3 stars, we begin to see how their brief but brilliant lives shaped the cosmos on the grandest scales. They were the pioneers of the universe, the ones who lit the darkness and laid the foundation for everything that followed. And while their light has long since faded, their impact continues to echo across the cosmos, a testament to their role in the story of creation. Yet, there's another invisible force at work in this cosmic drama, one that played a crucial role in shaping the universe even before the first stars ignited. This force, known as dark matter, doesn't emit light or interact with ordinary matter in the ways we're familiar with, but its gravitational influence is undeniable. In the early universe, dark matter acted as a cosmic scaffold, drawing gas and dust together to form the first stars and galaxies. Without it, the universe as we know it might never have come to be. As we explore the interplay between dark matter and star formation, we uncover yet another layer of the universe's complexity. From the first stars to the galaxies they helped create, every step in this journey has been shaped by the invisible hand of dark matter, guiding the cosmos from darkness into light. And as we peer deeper into the night sky, we're reminded that the story of the universe is not just about what we can see, but also about the unseen forces that shape its destiny. As we peer into the depths of the cosmos, we encounter a mystery that has puzzled scientists for decades: dark matter. This invisible substance, which makes up about 27% of the universe, doesn't emit, absorb, or reflect light, making it impossible to see directly. Yet its presence is undeniable, revealed through its gravitational effects on the visible universe. Without dark matter, the galaxies we see today spiraling, glowing, and teeming with stars might never have formed. The story of dark matter begins in the early universe, long before the first stars ignited. After the Big Bang, the cosmos was a sea of particles and energy, expanding rapidly. But as the universe cooled, gravity began to pull matter together. Ordinary matter, the stuff we can see, like hydrogen and helium gas, wasn't enough to overcome the universe's rapid expansion. Enter dark matter, a mysterious substance with mass but no interaction with light. Its gravitational pull acted as a cosmic glue, drawing gas and dust into dense clumps that would eventually become the seeds of galaxies. Dark matter's influence is most evident in the large-scale structure of the universe. Imagine a vast cosmic web, with filaments of dark matter stretching across billions of light years. These filaments form the backbone of the universe, guiding the flow of gas and dust into dense regions where galaxies and clusters of galaxies take shape. Without dark matter, this intricate web wouldn't exist, and the universe would be a far more scattered and less structured place. But dark matter's role doesn't stop at the cosmic scale. It also plays a critical part in the birth of individual stars. When a cloud of gas collapses under gravity to form a star, it's not just the visible matter that's at work. Dark matter, though invisible, contributes to the gravitational pull that triggers this collapse. In some cases, dark matter may even act as a kind of cosmic scaffolding, helping to stabilize gas clouds and make star formation more efficient. The interplay between dark matter and ordinary matter is a delicate dance, one that shapes the universe on every scale. While dark matter provides the gravitational framework, ordinary matter, like gas and dust, fills in the details, forming stars, planets, and all the visible structures we see. Together, they create the rich, dynamic cosmos we observe today. As we explore the mysteries of dark matter, we're reminded of how much of the universe remains unseen. This invisible force, though elusive, is essential to the story of creation. From the formation of the first stars to the intricate web of galaxies that spans the cosmos. And as we continue to search for answers, we uncover not just the secrets of dark matter, but the story of how the visible and invisible worlds are intertwined in the grand tapestry of the universe. This exploration of dark matter's role in star formation leads us to the next chapter in our journey, the birth of galaxies and the cosmic structures they form. From the smallest star to the largest galaxy cluster, the story of the universe is one of connection, collaboration, and the unseen forces that shape it all. In the grand cosmic dance, dark matter and visible matter are partners, each playing a vital role in shaping the universe we see today. While visible matter, the stars, gas, and dust, makes up everything we can observe, dark matter, invisible and elusive, provides the gravitational scaffolding that holds it all together. This interplay between the seen and the unseen is the key to understanding how galaxies form, evolve, and endure over billions of years. At the heart of this partnership are dark matter halos, vast, invisible structures that envelop galaxies like a cosmic embrace. These halos, composed entirely of dark matter, are the gravitational anchors that draw in gas and dust, allowing stars and galaxies to form. Without these halos, the universe would lack the structure we see today, its matter scattered and diffused. Instead, dark matter's gravitational pull creates dense regions where gas can cool, condense, and ignite into stars, giving rise to the galaxies that light up the cosmos. The distribution of stars within galaxies offers a glimpse into this hidden collaboration. In spiral galaxies like the Milky Way, stars orbit the center in a flat, rotating disk, while the dark matter halo extends far beyond, its influence felt but never seen. In elliptical galaxies, the stars are more randomly distributed, yet even here, dark matter's gravitational pull shapes their motion and structure. It's a delicate balance, one where the invisible guides the visible, creating the intricate patterns we observe in the night sky. Despite its crucial role, dark matter remains one of the greatest mysteries in modern science. We know it exists because of its gravitational effects, but what it's made of is still unknown. Is it composed of particles we haven't yet discovered? Does it interact with visible matter in ways we can't detect? These questions drive astronomers and physicists to push the boundaries of our understanding, using everything from particle colliders to space telescopes in the search for answers. As we explore the interplay between dark and visible matter, we're reminded of how much of the universe remains hidden from view. Yet, even in its invisibility, dark matter shapes the cosmos in profound ways, from the birth of stars to the formation of galaxies. And as we look deeper, we uncover not just the secrets of dark matter, but the story of how the visible and invisible worlds are intertwined in the grand tapestry of the universe. This intricate dance of matter and gravity leads us to another pivotal chapter in the universe's history, the concept of cosmic inflation. In the earliest moments after the Big Bang, the universe underwent an exponential expansion, stretching far faster than the speed of light. This rapid growth, driven by a mysterious force, laid the groundwork for the distribution of matter and energy we see today. It's a process that connects the smallest particles to the largest structures, shaping the cosmos on every scale and setting the stage for the formation of stars, galaxies, and everything in between. In the first moments after the Big Bang, the universe wasn't just born, it exploded into existence in a way that defies imagination. This explosive beginning, known as cosmic inflation, was a period of unimaginable expansion, where the universe grew exponentially in a fraction of a second. It's hard to grasp just how fast this was, faster than the speed of light, faster than anything we can measure. But this rapid expansion wasn't just about size. It was about laying the groundwork for everything that followed, including the stars and galaxies we see today. Cosmic inflation didn't just stretch space, it also created tiny ripples in the fabric of the universe, like waves on the surface of a pond. These ripples, known as quantum fluctuations, were the seeds of all structure in the cosmos. Imagine the universe as a blank canvas, and these fluctuations as the first brushstrokes, subtle, almost imperceptible, but carrying the potential for something extraordinary. Over time, gravity amplified these small differences in density, pulling matter together into denser regions. These regions would eventually become the birthplaces of stars, galaxies, and the vast cosmic web that connects everything we see. The connection between these early fluctuations and the universe we know today is profound. The denser regions became the hubs of star formation, where gas and dust gathered to ignite the first stars. The less dense areas remained as the vast voids we observe between galaxies. This pattern clusters of galaxies connected by filaments of dark matter and gas, separated by enormous empty spaces, is the large-scale structure of the universe, a direct result of those initial ripples from inflation. But cosmic inflation didn't just set the stage for stars and galaxies, it also influenced the universe's ongoing expansion. As stars formed and galaxies took shape, their gravitational pull began to shape the cosmos on a grand scale. The energy released by stars, particularly in supernova, contributed to the dynamic nature of the universe, driving the expansion of space itself. It's a feedback loop, where the birth and death of stars not only enrich the cosmos with heavy elements, but also play a role in its continued growth. This interplay between cosmic inflation and star formation reveals a deeper truth. The universe is a dynamic, ever-changing entity, shaped by forces both visible and invisible. From the tiniest quantum fluctuations to the largest galaxy clusters, every part of this story is interconnected, a testament to the unity of the cosmos. And as we look out at the night sky, we're not just seeing stars, we're witnessing the legacy of those first moments, when the universe was set in motion and the seeds of creation were sown. As we turn our gaze to the stars, we begin to see how their light and energy continue to shape the universe, driving its expansion and enriching its fabric. The story of cosmic inflation is just the beginning, a prologue to the ongoing saga of creation, destruction, and renewal that defines the cosmos. And as we explore further, we'll uncover how these stars, born from the echoes of the Big Bang, continue to illuminate the universe, guiding us through the mysteries of space and time. As we gaze at the night sky, filled with countless stars and galaxies, it's easy to see them as static points of light. But these celestial bodies are far more than just distant beacons. They are dynamic players in the ever-expanding universe, offering clues to one of the greatest mysteries in modern science, the accelerating expansion of the cosmos. Stars and galaxies are more than just cosmic landmarks. They are tools for measuring the vast distances of the universe. Among the most important of these tools are supernovae, particularly a type known as Type Ia supernova. These stellar explosions are so consistent in their brightness that they serve as standard candles, allowing astronomers to measure distances across the cosmos with remarkable precision. When a Type Ia supernova occurs, its peak brightness can be compared to its apparent brightness from Earth, revealing how far away it is. This method has been instrumental in mapping the universe and understanding its expansion. But the story of supernova doesn't end with distance measurements. In the late 1990s, astronomers made a startling discovery while studying these cosmic explosions. By observing distant Type Ia supernova, they found that the universe isn't just expanding, it's expanding at an accelerating rate. This revelation was like throwing a ball into the air and watching it speed up as it climbs, defying our expectations of how gravity should behave. The force driving this acceleration is still a mystery, but it's been given a name: dark energy. Dark energy is thought to make up about 68% of the universe, far more than the combined mass of all stars, galaxies, and even dark matter. Its presence suggests that the universe's expansion will continue to accelerate, potentially leading to a future where galaxies drift so far apart that they become invisible to one another. This discovery has profound implications for the ultimate fate of the cosmos, challenging our understanding of gravity, space, and time. While dark energy remains one of the greatest enigmas in science, stars and galaxies continue to shed light on its effects. By studying the distribution of galaxies and the brightness of supernova, astronomers can trace the history of the universe's expansion and probe the nature of dark energy itself. It's a cosmic detective story, where every star and galaxy holds a clue to unraveling the universe's deepest secrets. As we explore the role of stars in understanding the universe's expansion, we also uncover another fascinating field of study: stellar archaeology. This branch of astronomy looks at the oldest stars in the universe as relics of the past, offering insights into the early cosmos and the processes that shaped it. By studying the composition and motion of these ancient stars, we can piece together the history of the universe, from its fiery beginnings to its accelerating expansion today. The universe is a story written in starlight, a tale of creation, expansion, and transformation. And as we continue to explore its mysteries, we're reminded that every star, every galaxy, and every supernova is part of a larger narrative, one that connects us to the cosmos in ways we're only beginning to understand. Hidden within the vast expanse of the cosmos are ancient stars, celestial time capsules that hold the secrets of the universe's infancy. These stars, some nearly as old as the universe itself, are more than just distant points of light. They are windows into a time long before galaxies, planets, or even the first heavy elements existed. By studying these ancient relics, astronomers engage in a form of cosmic detective work known as stellar archaeology, piecing together the story of how the universe evolved from a sea of simple elements into the rich, complex tapestry we see today. The oldest stars, often found in the halos of galaxies or within globular clusters, are remarkably metal-poor. Unlike younger stars like our Sun, which contain traces of elements like carbon, oxygen, and iron, these ancient stars are composed almost entirely of hydrogen and helium, the raw materials left over from the Big Bang. Their pristine composition makes them invaluable to scientists, offering a snapshot of the universe's chemical makeup before generations of stars enriched it with heavier elements. To determine the age and composition of these stars, astronomers use a technique called spectroscopy. By analyzing the light emitted or absorbed by a star, they can identify the elements present in its atmosphere. Each element leaves a unique fingerprint in the star's spectrum, allowing scientists to measure its chemical makeup with remarkable precision. For the oldest stars, this analysis reveals a striking simplicity, a lack of heavy elements that points to their origins in a time when the universe was still in its formative stages. But stellar archaeology isn't just about understanding the past, it's also about tracing the universe's chemical evolution. As generations of stars lived, died, and exploded as supernova, they scattered heavy elements into the cosmos, enriching the interstellar medium and setting the stage for new stars and planets to form. The oldest stars act as benchmarks, marking the starting point of this process and helping scientists chart how the universe's chemical diversity has grown over billions of years. One of the most fascinating aspects of this research is what it reveals about the origins of the elements that make up our world, and even our bodies. The carbon in our DNA, the oxygen we breathe, and the iron in our blood were all forged in the hearts of stars and scattered by their explosive deaths. By studying ancient stars, we're not just uncovering the history of the cosmos, we're tracing the origins of the building blocks that make life possible. This connection between stellar archaeology and the search for extraterrestrial life is profound. If heavy elements are essential for the formation of planets and the emergence of life, then understanding how and when these elements first appeared in the universe could help us identify the conditions necessary for life to arise elsewhere. The oldest stars, with their pristine composition, remind us of how far the universe has come and how much it has yet to reveal. As we continue to explore these ancient relics, we're not just studying the past, we're uncovering the story of how the universe became a place capable of supporting life. And as we look to the stars, we're reminded that the search for extraterrestrial life isn't just about finding other worlds, it's about understanding the cosmic processes that made our own existence possible. Among the countless stars that dot the night sky, one question burns brighter than the rest. Could life exist beyond Earth? The search for extraterrestrial life is deeply intertwined with the stars themselves, as these celestial bodies not only provide the light and energy needed for life, but also shape the conditions under which it might thrive. From the warmth of a star's habitable zone to the unpredictable storms of stellar flares, stars play a pivotal role in determining whether a planet can support life and what that life might look like. At the heart of this search is the concept of the habitable zone, often referred to as the Goldilocks zone. This is the region around a star where temperatures are just right, not too hot, and not too cold for liquid water to exist on a planet's surface. Water, as we know it, is essential for life, making the habitable zone a key factor in assessing a planet's potential to host living organisms. For a star like our Sun, this zone lies roughly between the orbits of Venus and Mars, with Earth sitting comfortably in the middle. But the habitable zone isn't a fixed boundary. It shifts depending on the star's size, temperature, and brightness. Smaller, cooler stars, like red dwarfs, have much closer habitable zones, while larger, hotter stars have zones that are farther out. However, a planet's location within the habitable zone is just the beginning of the story. Stellar activity, such as flares and radiation, can dramatically influence a planet's suitability for life. Red dwarfs, for example, are known for their frequent and intense flares, sudden bursts of energy that can strip away a planet's atmosphere or bombard it with harmful radiation. While these stars are abundant and long-lived, their volatile nature poses significant challenges for habitability. On the other hand, stars like our Sun are more stable, offering a gentler environment for life to potentially emerge and evolve. Yet, even the Sun isn't entirely predictable. Solar flares and coronal mass ejections can disrupt planetary climates, highlighting the delicate balance required for life to thrive. The search for extraterrestrial life also extends to the chemical composition of stars and their planets. Stars rich in heavy elements like carbon, oxygen, and nitrogen are more likely to host planets with the building blocks necessary for life. These elements, forged in the hearts of stars and scattered across the cosmos by supernova, are the raw materials for everything from organic molecules to complex ecosystems. By studying the chemistry of stars, astronomers can identify systems with the greatest potential for harboring life, narrowing the search for Earth-like worlds in the vastness of space. As we explore the role of stars in the search for life, we're reminded of their dual nature, both creators and destroyers, nurturing planets with light and warmth, while also unleashing forces that can reshape entire worlds. This delicate interplay between stars and their planetary systems is a testament to the complexity of the universe, a place where life, if it exists, must navigate a precarious balance of conditions. Looking ahead, the future of stars also holds clues to the fate of life in the universe. As stars age and evolve, their habitable zones shift, potentially rendering once hospitable planets uninhabitable. Meanwhile, the formation of new stars in stellar nurseries offers the possibility of fresh opportunities for life to arise. The universe is a dynamic, ever-changing place, and the stars that light it are both the architects and the harbingers of its future. From the smallest red dwarf to the most massive blue giant, every star holds the potential to shape the story of life in the cosmos. As we continue our search for extraterrestrial life, we're not just looking for planets, we're exploring the intricate relationship between stars and the worlds they nurture, uncovering the cosmic conditions that make life possible. And in doing so, we're reminded that the stars above are more than just distant points of light. They are the keepers of the universe's greatest mysteries, guiding us toward answers that could change our understanding of existence itself. As we turn our gaze to the next chapter of this cosmic journey, we'll explore how the life cycles of stars influence the evolution of galaxies, shaping the universe on the grandest scales and leaving a legacy that echoes across billions of years. As we gaze at the stars today, it's easy to forget that their light is a fleeting glimpse of an ever-changing universe. Stars, like all things, have a finite existence, and their long-term fate is tied to the ultimate destiny of the cosmos itself. Over trillions of years, the universe will undergo profound transformations, and the stars we see now will fade, leaving behind remnants that slowly dissolve into the void. This is the story of the future of stars, a tale of cooling, decay, and the inexorable march of time. Let's start with white dwarfs, the remnants of stars like our Sun. After shedding their outer layers and leaving behind glowing planetary nebulae, these dense cores gradually cool over billions of years. Imagine a once bright star, now a faint ember, radiating its residual heat into the cold expanse of space. Over time, this heat dissipates and the white dwarf dims further, eventually becoming a cold, dark object known as a black dwarf. These stellar relics, though invisible, will drift through the cosmos as silent monuments to the stars that once were. Neutron stars, the ultra-dense remnants of massive stars, face a different fate. Over unimaginable timescales, these spinning behemoths will lose their energy, their rapid rotations slowing as they emit gravitational waves and electromagnetic radiation. Eventually, they too will cool, their surfaces freezing into exotic states of matter. Some theories even suggest that neutron stars may evaporate over trillions of years, their particles slowly escaping into the void. This process, though incredibly slow, is a reminder that even the most extreme objects in the universe are not eternal. Then there are black holes, the most enigmatic remnants of all. While they seem invincible, even black holes are not immune to the passage of time. Through a process known as Hawking radiation, black holes slowly lose mass, emitting energy until they eventually evaporate entirely. For stellar mass black holes, this process takes far longer than the current age of the universe, but over countless eons, even these cosmic titans will fade away, leaving behind only a faint whisper of their former power. As stars and their remnants cool and decay, the universe itself will continue to expand, growing colder and darker with each passing eon. This eventual state, known as heat death, is a scenario where all energy is evenly distributed and no more work can be done. It's a universe where stars no longer shine, where galaxies have long since drifted apart, and where the cosmos has reached a state of maximum entropy. While this may sound bleak, it's also a reminder of the incredible journey the universe has taken from the fiery birth of the first stars to the cold, quiet expanse of its future. Yet, even in this distant future, the legacy of stars endures. Every atom in our bodies, every planet in our solar system, and every galaxy in the sky is a product of stellar life and death. Stars are the architects of the cosmos, shaping its structure and enriching it with the elements necessary for life. They are the beacons that guide our understanding of the universe, illuminating its past, present, and future. As we reflect on the fate of stars, we're reminded of their profound significance. They are not just distant points of light, they are the storytellers of the cosmos, narrating a tale of creation, destruction, and the enduring beauty of existence. And as we continue to explore their mysteries, we uncover not just the secrets of the universe, but our place within it, a fleeting moment in the grand, unfolding story of the stars. This journey through the lives and fates of stars brings us to the next chapter of our exploration, the role of stars in the evolution of galaxies, and how their light and energy continue to shape the universe on the grandest scales. From the birth of the first stars to the ultimate fate of the cosmos, the story of stars is a testament to the interconnectedness of all things in the universe. Stars are more than just distant points of light in the night sky. They are the keys to unlocking the mysteries of the universe. Over centuries, the study of stars has transformed our understanding of the cosmos, reshaping not only astronomy but also physics, chemistry, and even philosophy. From Galileo's first telescopic observations to the cutting-edge data from modern space observatories, stars have been at the heart of humanity's quest to comprehend the vast, intricate tapestry of existence. One of the most profound contributions of stellar research lies in its role in advancing our understanding of fundamental physics, the discovery of nuclear fusion, the process that powers stars, revolutionized science, revealing how atoms combine to release energy on a scale that defies imagination. This insight didn't just explain how stars shine, It also opened the door to harnessing nuclear energy here on Earth, demonstrating how the study of the cosmos can have tangible, transformative impacts on our daily lives. Stars have also served as cosmic laboratories, allowing scientists to test and refine theories about gravity, light, and the behavior of matter under extreme conditions. For instance, the study of binary star systems, where two stars orbit each other, provided some of the earliest evidence supporting Einstein's theory of general relativity. These systems, with their intricate gravitational dances, continue to offer insights into the nature of space and time, pushing the boundaries of our knowledge. But the significance of stars extends beyond the realm of physics. They are the storytellers of the universe, chronicling its history through their light. By analyzing the spectra of stars, astronomers can trace the chemical evolution of the cosmos, uncovering how the first elements formed and how they've been enriched over billions of years. This cosmic archaeology reveals not just the origins of stars, but also the origins of the elements that make up our world, and even our bodies. Yet, for all that we've learned, stars still hold countless mysteries. What triggers the formation of the first stars in the early universe? How do massive stars end their lives, and what happens to their remnants? And perhaps most tantalizing of all, could stars harbor planets capable of supporting life? These questions drive astronomers to peer deeper into the cosmos, using ever more powerful telescopes to unravel the secrets of stellar birth, life, and death. As we reflect on the role of stars in shaping our understanding of the universe, it's impossible to ignore their cultural and mythological significance. For millennia, humans have looked to the stars for guidance, inspiration, and meaning. From the constellations that guided ancient navigators to the myths that connected civilizations to the heavens, stars have always been more than just celestial objects. They are symbols of curiosity, wonder, and the unending quest for knowledge. This deep connection between stars and human culture brings us to the next chapter of our journey, the mythology and cultural significance of stars. From ancient stories etched in the night sky to modern interpretations of the cosmos, the stars have always been a mirror reflecting our dreams, fears, and aspirations. And as we explore these stories, we're reminded that the study of stars is not just about understanding the universe, it's about understanding ourselves. Since the dawn of humanity, the stars have been more than just luminous points in the night sky. They have been storytellers, guides, and symbols of the divine. Across cultures and civilizations, stars have inspired myths, shaped traditions, and served as celestial maps for explorers and dreamers alike. From the ancient Greeks to the indigenous peoples of the Americas, the stars have woven themselves into the fabric of human culture, becoming a universal language of wonder and imagination. One of the earliest and most enduring roles of stars in human history is their use in navigation. Long before the invention of compasses or GPS, sailors and travelers relied on the positions of stars to chart their courses across vast oceans and deserts. The North Star, or Polaris, became a steadfast beacon for mariners in the Northern Hemisphere, its fixed position in the sky offering a reliable point of reference. In the Southern Hemisphere, the Southern Cross served a similar purpose, guiding explorers through uncharted waters. These celestial landmarks were more than tools, they were lifelines, connecting distant lands and cultures through the shared knowledge of the stars. Stars also played a crucial role in timekeeping, helping ancient civilizations mark the passage of seasons and the cycles of agriculture. The Egyptians, for instance, used the rising of Sirius, the brightest star in the night sky, to predict the annual flooding of the Nile, an event that was vital for their crops. Similarly, the Mayans developed intricate calendars based on the movements of celestial bodies, aligning their rituals and daily lives with the rhythms of the cosmos. These practices reveal a deep understanding of the stars, not just as distant lights, but as integral parts of human survival and progress. Beyond their practical uses, stars have been central to the myths and legends that define cultures around the world. In Greek mythology, the constellations were immortalized as gods, heroes, and creatures, their stories written in the stars for all to see. Orion, the mighty hunter, and Andromeda, the chained princess, are just two examples of how the night sky became a canvas for epic tales. Indigenous cultures, too, saw the stars as more than mere points of light. For the Maori of New Zealand, the Pleiades star cluster, or Matariki, marked the beginning of the new year and was celebrated as a time of renewal and remembrance. This cultural fascination with the stars has endured into the modern era, bridging the gap between ancient wisdom and contemporary science. Today, the same constellations that guided ancient navigators and inspired mythmakers are studied by astronomers, who use them to explore the mysteries of the universe. The stories of the stars, once told around campfires and etched into stone, now inform our understanding of stellar evolution, black holes, and the origins of the cosmos. Yet, even as our scientific knowledge expands, the stars retain their power to inspire awe and curiosity. They remind us that, for all our technological advancements, we are still driven by the same questions that captivated our ancestors. What lies beyond our world? Are we alone in the universe? And what does it mean to be part of something so vast and ancient? As we look to the stars today, we're not just seeking answers to scientific questions, we're continuing a tradition that spans millennia. The stars are a bridge between the past and the present, connecting us to the cultures and civilizations that came before, and to the future discoveries that await us. And as we turn our gaze to the next chapter of this journey, we'll explore how modern science has built upon this ancient fascination, using the light of the stars to unlock the secrets of the cosmos. The night sky has always been a source of wonder, but it wasn't until the invention of the telescope in the early 17th century that humanity began to truly unlock its secrets. Today, the tools we use to study the stars are more advanced than ever, allowing us to peer deeper into the cosmos and uncover phenomena that were once beyond our reach. From towering ground-based observatories to cutting-edge space telescopes, these instruments have transformed our understanding of the universe, revealing the intricate details of stellar birth, life, and death. Ground-based telescopes, like those perched on mountain peaks in Chile or Hawaii, have long been the workhorses of astronomy. These massive instruments, equipped with mirrors that can span several meters, collect light from distant stars and galaxies, providing detailed images and spectra that reveal their composition, temperature, and motion. Advances in adaptive optics, technology that corrects for the blurring effects of Earth's atmosphere, have made these telescopes even more powerful, allowing astronomers to capture images with unprecedented clarity. But the real game changer has been the launch of space telescopes, free from the distortions of Earth's atmosphere. The Hubble Space Telescope, launched in 1990, has become an icon of modern astronomy, delivering breathtaking images of distant galaxies, nebulae, and star clusters. Hubble's observations have deepened our understanding of everything from the life cycles of stars to the expansion of the universe, earning it a place as one of the most important scientific instruments in history. Now, the James Webb Space Telescope is taking stellar exploration to new heights. Launched in late 2021, Webb is designed to observe the universe in infrared light, revealing details hidden by cosmic dust and offering a glimpse into the earliest stages of star formation. Its ability to peer into the hearts of stellar nurseries and analyze the atmospheres of distant exoplanets is already reshaping our understanding of the cosmos, providing insights that were unimaginable just a few decades ago. Yet, the study of stars isn't limited to professional astronomers. Citizen science projects have opened the door for anyone with an interest in the cosmos to contribute to real scientific research. Programs like Zooniverse allow volunteers to analyze data from telescopes, helping to identify new stars, classify galaxies, or even search for signs of extraterrestrial life. This democratization of astronomy not only accelerates research, but also fosters a deeper connection between the public and the stars, reminding us that the night sky belongs to everyone. From the first primitive telescopes to the sophisticated instruments of today, our ability to explore the cosmos has grown exponentially. Each new tool brings us closer to understanding the mysteries of the stars, revealing the beauty and complexity of the universe in ways that inspire both awe and curiosity. And as we continue to push the boundaries of technology, one thing is certain: the stars will always have more stories to tell. As we reflect on the incredible advancements in stellar exploration, it's worth considering how these discoveries impact our understanding of the universe's origins and its future. The tools we use to study the stars not only reveal their secrets, but also help us piece together the grand narrative of the cosmos, a story that began with the first light of the Big Bang and continues to unfold with every new observation. The universe is vast, and its secrets are too numerous for professional astronomers to uncover alone. Enter citizen scientists, everyday stargazers, and curious minds who contribute to groundbreaking discoveries from their backyards, living rooms, and classrooms. These amateur astronomers, armed with little more than passion and a keen eye, have become invaluable partners in the quest to understand the stars. Through collaborative projects, they've helped identify new celestial objects, classify galaxies, and even uncover phenomena that might have otherwise gone unnoticed. One of the most remarkable examples of this collective effort is Galaxy Zoo, a project that invites volunteers to classify galaxies based on images from telescopes. Since its launch in 2007, hundreds of thousands of participants have analyzed millions of galaxy images, helping scientists map the universe's structure and uncover rare objects like merging galaxies and supermassive black holes. What's extraordinary is that many of these discoveries were made by people with no formal training in astronomy, just a love for the cosmos and a desire to contribute to something bigger than themselves. But Galaxy Zoo is just the beginning. Other citizen science projects have led to equally astonishing finds. Take, for instance, the discovery of yellow balls by participants in the Milky Way project. These mysterious objects, initially dismissed as artifacts in telescope images, turned out to be early-stage star-forming regions, shedding light on how stars are born. Similarly, amateur astronomers have played a key role in spotting supernova, variable stars, and even exoplanets, proving that the night sky holds endless opportunities for discovery, no matter who's looking. What makes citizen science so powerful is its ability to democratize astronomy. By breaking down barriers and inviting everyone to participate, these projects not only accelerate research, but also foster a deeper connection between people and the cosmos. They remind us that the stars aren't just the domain of scientists, they belong to all of us, and anyone can contribute to unraveling their mysteries. This spirit of collaboration and discovery extends beyond data analysis. In recent years, a new form of engagement has emerged: stellar art. Combining science and creativity, artists and enthusiasts use astronomical data to create stunning visualizations of stars, nebulae, and galaxies. These works, often based on real telescope images, transform raw data into vivid, imaginative representations that captivate the public and make the wonders of the cosmos more accessible. Stellar art isn't just about beauty, it's a bridge between science and the public, a way to inspire curiosity and spark conversations about the universe. Whether it's a painting of a distant nebula or a digital rendering of a star's life cycle, these creations remind us that the cosmos is not only a place of discovery, but also a source of endless inspiration. As we reflect on the contributions of citizen scientists and the power of stellar art, we're reminded that the stars are more than just objects of study. They are a shared heritage, a source of wonder that unites us all. And as we turn our gaze to the next chapter of this journey, we'll explore how the stories we tell about the stars, whether through science, art, or myth, continue to shape our understanding of the universe and our place within it. Gazing at the stars has always stirred something deep within us, a sense of wonder, curiosity, and connection to the cosmos. But what happens when science and art come together to translate that cosmic beauty into something tangible? This is the realm of stellar art, where the analytical precision of astronomy meets the boundless creativity of human expression. Through this unique collaboration, artists and scientists are not only illuminating the mysteries of the universe, but also making them accessible to everyone. Stellar art begins with raw, intricate information captured by telescopes and space probes. Artists take this data, often in the form of images or spectral readings, and transform it into breathtaking visualizations. These aren't just artistic interpretations, they're grounded in science, using real observations to depict stars, nebulae, and galaxies in ways that are both accurate and awe-inspiring. For example, the iconic images of the pillars of creation, captured by the Hubble Space Telescope, have been reimagined by artists to highlight their ethereal beauty, bringing the distant reaches of the Eagle Nebula to life in vivid detail. But stellar art isn't just about creating pretty pictures. It plays a vital role in communicating complex scientific ideas to the public. Take black holes, for instance. These enigmatic objects are invisible to the naked eye, yet through the collaboration of artists and scientists, we've been able to visualize them. The groundbreaking image of the supermassive black hole in the galaxy M87, released in 2019, was the result of years of data collection and meticulous artistic rendering. By blending science with creativity, this image made the invisible visible, helping people around the world grasp the concept of a black hole in a way that equations alone never could. The emotional impact of stellar art is just as profound as its educational value. Whether it's a painting of a dying star or a digital animation of a supernova, these creations evoke a sense of awe and humility, reminding us of our place in the vastness of the cosmos. They tap into the universal fascination with the night sky, connecting us to the stars in ways that transcend language and culture. For many, these artistic depictions are more than just visuals. They are windows into the soul of the universe, offering a glimpse of its beauty, mystery, and grandeur. This connection between art and science isn't just one way. Scientists, too, find inspiration in artistic representations of their work. Visualizations can reveal patterns or details that might otherwise go unnoticed, sparking new questions and avenues of research. In this way, Stellar art isn't just a tool for communication, it's a catalyst for discovery, bridging the gap between imagination and exploration. As we reflect on the power of stellar art, we're reminded of the emotional resonance that stars hold for humanity. They've inspired myths, guided explorers, and sparked countless dreams. Through art, we can continue to share that wonder, inviting others to look up at the night sky and feel the same sense of awe that has captivated us for millennia. This journey through the intersection of science and creativity brings us to the next chapter of our exploration, the emotional and psychological impact of stars on humanity. From ancient myths to modern dreams, the stars have always been more than just celestial objects. They are mirrors reflecting our deepest hopes, fears, and aspirations. And as we delve into this connection, we uncover how the light of the stars continues to shape not just our understanding of the universe, but also our understanding of ourselves. There's something profoundly moving about standing under a clear night sky, gazing up at the countless stars that stretch endlessly into the void. For millennia, these celestial lights have stirred emotions deep within us: awe, wonder, and a sense of connection to something far greater than ourselves. Stars are more than just physical phenomena. They are symbols of inspiration, catalysts for creativity, and mirrors reflecting humanity's deepest thoughts and dreams. Across cultures and eras, stars have held a special place in the human imagination. In literature, they've been metaphors for hope, guidance, and the eternal. Think of Shakespeare's plays, where stars are often invoked to symbolize destiny, as in Romeo and Juliet. It is the east and Juliet is the sun. Or consider the poetry of the Romantic era, where stars became emblems of the sublime, evoking both beauty and the infinite. From ancient epics to modern novels, the night sky has been a canvas for storytelling, a backdrop against which humanity's greatest dramas unfold. Music, too, has been shaped by the stars. From classical compositions like Gustav Holst's The Planets to modern anthems like Elton John's Rocket Man, the cosmos has inspired melodies that capture both the grandeur and the mystery of the universe. Even in everyday life, we turn to the stars for metaphors, singing about stardust, dreaming of starry nights, and imagining ourselves as shooting stars. These artistic expressions remind us that stars are not just distant lights, they are part of our cultural fabric, woven into the songs and stories that define who we are. Philosophy, perhaps more than any other discipline, has grappled with the emotional weight of the stars. For thinkers like Immanuel Kant, the starry sky above was a source of moral reflection, a reminder of humanity's place in the vastness of existence. The night sky has always invited contemplation of our origins, our purpose, and our interconnectedness with the cosmos. It's no wonder that astronomers like Carl Sagan often spoke of the stars as a way to unite humanity, their light transcending borders, cultures, and time itself. This universal connection to the stars is deeply rooted in our shared human experience. Whether you're standing on a mountaintop, gazing at the Milky Way, or sitting in a city park, catching a rare glimpse of a single star through the light pollution, the feeling is the same, a profound sense of wonder and humility. The stars remind us that we are part of something vast and beautiful, a cosmic story that began billions of years ago and continues to unfold with every passing moment. Yet, as much as stars inspire us, they also face challenges. Light pollution, a byproduct of modern life, is slowly dimming our view of the night sky, robbing future generations of the chance to experience its wonder. This brings us to the concept of stellar conservation, an effort to preserve our connection to the stars by protecting the night sky from artificial light. It's a reminder that the stars are not just distant objects to admire. They are a shared heritage, one that requires care and stewardship to ensure their beauty endures for generations to come. As we reflect on the emotional impact of stars, we're reminded of their dual role in our lives, as sources of inspiration and as fragile treasures that need our protection. The night sky is more than just a backdrop for our stories. It's a living, breathing part of our collective identity, a reminder of the beauty and mystery that bind us all. And as we turn our attention to the next chapter of this journey, we'll explore how we can safeguard this celestial legacy, ensuring that the stars continue to light our way for centuries to come. As we marvel at the beauty and mystery of the stars, there's a growing concern that threatens our ability to connect with the night sky: light pollution. This pervasive glow from artificial lights doesn't just obscure the stars, it disrupts ecosystems, wastes energy, and severs our connection to the cosmos. Protecting the night sky isn't just about preserving a view, it's about safeguarding a shared human heritage and ensuring that future generations can experience the wonder of a star-filled sky. Light pollution has a profound impact on astronomical research. For astronomers, both professional and amateur, clear, dark skies are essential for observing distant stars, galaxies, and other celestial phenomena. The faint light from these objects can be easily drowned out by the glare of streetlights, billboards, and urban sprawl. This interference doesn't just hinder scientific discovery, it limits our understanding of the universe and the stories it has to tell. Telescopes, no matter how advanced, can't compensate for a sky flooded with artificial light. Beyond science, the loss of dark skies affects our cultural and emotional connection to the stars. For thousands of years, humans have looked to the night sky for guidance, inspiration, and a sense of place in the universe. Constellations have shaped myths, guided explorers, and sparked the imaginations of poets and dreamers. When light pollution dims the stars, it dims that connection, erasing a source of wonder that has inspired humanity for millennia. Thankfully, there's hope. Around the world, efforts are underway to protect and restore dark skies. Organizations like the International Dark Sky Association work to designate dark sky places areas where light pollution is minimized and the night sky is preserved. These sanctuaries, ranging from remote deserts to national parks, offer a glimpse of the sky as it once was, free from the glow of modern life. Communities are also taking action, adopting responsible lighting practices that reduce glare and light trespass while still ensuring safety and visibility. Technology, too, is playing a role in the fight against light pollution. Innovations in lighting design, such as shielded fixtures and energy-efficient LEDs, allow us to illuminate our world without overwhelming the night sky. By directing light where it's needed and using warmer, less intrusive colors, we can strike a balance between progress and preservation. These solutions not only protect the night sky, but also save energy and reduce our environmental footprint. As we look to the future, the preservation of dark skies is more than just an environmental or scientific issue. It's a call to reconnect with the cosmos. Imagine a world where every child can step outside and see the Milky Way stretching across the sky, where the stories of the stars are not just tales from the past, but living, breathing parts of our shared experience. Protecting the night sky is about preserving that sense of wonder, ensuring that the stars continue to inspire and unite us, just as they have for generations. This effort to protect the night sky naturally leads us to consider the future of stellar research. With advancements in technology and a growing commitment to preserving dark skies, the possibilities for discovery are endless. From unraveling the mysteries of dark matter to exploring the atmospheres of distant exoplanets, the stars hold countless secrets waiting to be uncovered. And as we continue to explore, we're reminded that the story of the universe is still being written, a story that begins with the light of the stars and extends far beyond what we can see. As we look toward the horizon of stellar research, the future shines brighter than ever, fueled by cutting-edge technologies and ambitious missions poised to revolutionize our understanding of the cosmos. The stars, once distant and enigmatic, are becoming more accessible thanks to advancements that push the boundaries of what we can observe and explore. From next-generation telescopes to missions designed to uncover the secrets of distant worlds, the tools of tomorrow promise to illuminate the universe in ways we've only begun to imagine. One of the most exciting developments on the horizon is the Vera Rubin Observatory, set to begin operations in the coming years. Nestled high in the Chilean Andes, this state-of-the-art facility will conduct the legacy survey of space and time, capturing an unprecedented view of the night sky. Over 10 years, it will map billions of stars, galaxies, and other celestial objects, creating a dynamic, time-lapse portrait of the universe. This survey isn't just about cataloging the cosmos, it's about uncovering the hidden patterns and movements that shape it, from the orbits of distant asteroids to the subtle flickers of stars that might signal the presence of exoplanets. But the Vera Rubin Observatory is just the beginning. The James Webb Space Telescope, already transforming our view of the cosmos, is set to delve even deeper into the mysteries of star formation and the atmospheres of distant worlds. By analyzing the light from exoplanets, Webb can identify chemical signatures that might hint at the presence of water, oxygen, or even signs of life. This search for habitable exoplanets is one of the most thrilling areas of modern astronomy, offering the tantalizing possibility that we might one day find another Earth orbiting a distant star. Meanwhile, ground-based observatories like the extremely large telescope, currently under construction in Chile, will bring unprecedented resolution to our observations. With a mirror nearly 40 meters wide, this telescope will allow us to peer into the hearts of stellar nurseries, study the atmospheres of exoplanets in exquisite detail, and even observe the formation of planets around young stars. These missions aren't just about answering existing questions, they are about uncovering new ones, revealing phenomena we can't yet imagine. Yet, even with these advancements, the stars remain full of mysteries. What triggers the formation of the first stars in the early universe? How do massive stars end their lives? And what happens to their remnants? And perhaps most intriguing of all, could stars beyond our solar system host planets capable of sustaining life? These questions remind us that, for all we've learned, the cosmos still holds countless secrets waiting to be uncovered. As we stand on the brink of this new era of discovery, it's impossible not to feel a sense of excitement and wonder. The stars have guided us for millennia, lighting the way for explorers, dreamers, and scientists alike. And as we continue to explore their mysteries, we're reminded that the universe is not just a place of answers, it's a place of endless possibilities, where every discovery opens the door to new questions and new adventures. This journey into the future of stellar research leads us to the next chapter of our exploration, the enduring legacy of stars and their role in shaping not just the cosmos, but also our place within it. From the first light of the Big Bang to the distant worlds we're only beginning to discover, the stars continue to illuminate the path forward, guiding us toward a deeper understanding of the universe and our place within its grand tapestry. For all the incredible discoveries we've made about stars, how they form, evolve, and die, there's still so much we don't know. The universe is a vast puzzle, and stars are some of its most intriguing pieces, holding secrets that challenge our understanding of physics, time, and the very fabric of reality. These enduring mysteries aren't just gaps in our knowledge, they're invitations to explore, to push the boundaries of what's possible, and to uncover truths that could reshape our view of the cosmos. Take dark matter, for example. We know it exists because of its gravitational effects on galaxies and galaxy clusters, but what is it made of? How does it interact with ordinary matter, if at all? Stars, especially those in the outer regions of galaxies, orbit faster than they should based on the visible matter alone. This discrepancy points to the presence of dark matter, an invisible substance that makes up about 27% of the universe. Yet, despite decades of research, dark matter remains elusive, a cosmic ghost that defies detection. Solving this mystery could unlock some of the universe's deepest secrets, from the formation of galaxies to the ultimate fate of the cosmos. Then there are the population Roman 3 stars, the universe's first generation of stars. These ancient giants, born from the pure hydrogen and helium of the early cosmos, are thought to have been hundreds of times more massive than our Sun. But because they lived and died so quickly, we've never directly observed one. Their existence is inferred from the chemical fingerprints they left behind, enriching the universe with the first heavy elements. Finding evidence of these primordial stars would be like discovering the missing link in cosmic history, offering a glimpse into the universe's fiery beginnings and the origins of everything we see today. And what about the ultimate fate of the universe? Stars, in their life cycles, give us clues about the cosmos's past, but they also hint at its future. Will the universe continue expanding forever, growing colder and darker as stars fade away? Or will it collapse back in on itself in a cosmic reversal known as the Big Crunch? The answers lie in the delicate balance between dark energy, the mysterious force driving the universe's accelerating expansion, and gravity, the force that holds everything together. Stars, as both creators and destroyers, play a pivotal role in this cosmic drama, their lives and deaths shaping the destiny of the universe itself. These unanswered questions aren't just academic curiosities, they're the driving force behind astronomy's most ambitious projects. From building more powerful telescopes to launching missions that probe the farthest reaches of space, scientists are constantly pushing the limits of technology and imagination to uncover the truth. Each discovery, no matter how small, adds another piece to the puzzle, bringing us closer to understanding the universe's grand design. As we stand on the brink of these new frontiers, it's worth reflecting on what makes these mysteries so compelling. They remind us that the universe is far stranger and more wonderful than we can imagine, filled with phenomena that challenge our understanding and spark our curiosity. The stars, with their light and energy, are more than just distant objects. They are beacons guiding us toward a deeper understanding of the cosmos and our place within it. This ongoing quest for knowledge isn't just about stars, it's about the broader narrative of cosmic exploration. Each mystery we unravel, each question we answer, brings us closer to understanding the universe as a whole, from the tiniest particles to the largest structures. And as we continue to explore, we're reminded that the story of the stars is also the story of us, a journey of discovery that connects us to the cosmos in ways that are both profound and deeply personal. As we delve deeper into the mysteries of the stars, it becomes clear that their study is just one piece of a much larger puzzle. The stars are not isolated phenomena, They are threads in the intricate tapestry of the universe, connecting us to broader questions about the cosmos itself. From the origins of galaxies to the search for life beyond Earth, stellar research is a gateway to understanding the universe on the grandest scales. At its core, cosmology, the study of the universe's origin, structure, and ultimate fate, relies heavily on what we learn from stars. These celestial objects act as cosmic beacons, illuminating the history and evolution of the universe. For instance, the light from distant stars and galaxies allows us to peer billions of years into the past, offering a glimpse into the universe's infancy. By analyzing this light, cosmologists can trace the expansion of the universe, map the distribution of galaxies, and even uncover the nature of dark energy, the mysterious force driving the cosmos apart. But the connections go even deeper. Stars are the engines of cosmic chemistry, forging the elements that make up everything we see around us. From the carbon in our DNA to the oxygen we breathe, these elements were born in the hearts of stars and scattered across the universe by their explosive deaths. This process, known as stellar nucleosynthesis, is the foundation of the universe's chemical diversity, shaping the conditions for planets, life, and even the possibility of extraterrestrial civilizations. This brings us to one of the most profound questions in science. Are we alone in the universe? The search for extraterrestrial life, or astrobiology, is deeply intertwined with the study of stars. By identifying stars with habitable zones, regions where liquid water could exist on orbiting planets, we narrow the search for potentially life-bearing worlds. Telescopes like the James Webb Space Telescope are now analyzing the atmospheres of exoplanets, looking for chemical signatures that might hint at the presence of life. It's a thrilling intersection of stellar research and astrobiology, where the light of distant stars could one day reveal the existence of other living beings. Yet, even as we explore these cosmic connections, we're reminded that the stars are more than just subjects of study. They are guides on our journey of discovery. They inspire us to ask big questions, to push the boundaries of knowledge, and to dream of what lies beyond our world. Whether we're mapping the expansion of the universe or searching for life on distant planets, the stars are our constant companions, lighting the way forward. This cosmic exploration is not just about answering questions, it's about understanding our place in the universe. Every star we study, every galaxy we map, and every exoplanet we analyze brings us closer to seeing the bigger picture, a universe that is vast, dynamic, and full of wonder. And as we continue to explore, we're reminded that the story of the stars is also the story of us, a journey that connects us to the cosmos in ways both profound and deeply personal. With every discovery, we take another step in this grand cosmic journey, guided by the light of the stars and the endless curiosity they inspire. And as we look to the future, we can only imagine what new wonders await us in the vast, uncharted reaches of the universe. Throughout human history, stars have been far more than distant points of light in the night sky. They've been our guides, our teachers, and our inspiration. Long before the invention of telescopes or satellites, ancient civilizations looked to the stars for navigation, timekeeping, and even storytelling. The Polynesians, for instance, used the positions of stars to traverse vast stretches of the Pacific Ocean, their knowledge of celestial patterns guiding them to new lands. Similarly, the Babylonians and Greeks mapped the heavens, creating constellations that not only helped them navigate, but also became the foundation of myths and legends that endure to this day. Fast forward to the modern era, and stars continue to shape our exploration of the cosmos. They are the beacons that guide spacecraft, the the laboratories where we test the laws of physics, and the inspiration behind humanity's boldest missions. Think of the Apollo program, which carried humans to the moon under the light of stars that had guided explorers for millennia, or consider the Voyager probes, now venturing beyond our solar system, carrying messages intended for beings who might one day find them under the same stars we see from Earth. But stars don't just illuminate our past, they light the way to our future. For generations of scientists, engineers, and dreamers, the night sky has been a source of endless curiosity and motivation. The mysteries of black holes, the search for habitable exoplanets, and the quest to understand dark energy all stem from our desire to unravel the secrets of the stars. They remind us that the universe is vast, full of possibilities waiting to be discovered, and that we are part of a story much larger than ourselves. This brings us to the concept of stellar storytelling, a way of weaving the science of stars with the narratives that connect us to the cosmos. From the myths of Orion and Andromeda to the latest discoveries from space telescopes, stars have always been storytellers, offering us a way to make sense of the universe and our place within it. They are more than just celestial objects, they are symbols of hope, exploration, and the enduring human spirit. As we continue to explore the cosmos, we're reminded that the stars are not just distant lights, they are part of our journey, shaping who we are and who we might become. They inspire us to look beyond our world, to dream of new horizons, and to ask the questions that drive us forward. And as we turn our gaze to the next chapter of this cosmic story, we'll explore how the tales we tell about the stars continue to shape our understanding of the universe and ourselves. What if the stories of the stars could inspire not just scientists, but everyone? Across the globe, astronomers, educators, and storytellers are bridging the gap between the cosmos and the public, transforming complex scientific discoveries into narratives that spark wonder and curiosity. This is the power of stellar storytelling, a way to share the universe's most profound mysteries in ways that resonate with people from all walks of life. Science communication plays a vital role in making the cosmos accessible. Through books, documentaries, podcasts, and social media, scientists and communicators break down intricate concepts like stellar evolution, black holes, and exoplanets into relatable, engaging stories. Take, for example, Carl Sagan's Cosmos, a groundbreaking series that brought the beauty and complexity of the universe into living rooms around the world. By weaving science with poetry and philosophy, Sagan didn't just inform, he inspired millions to look up at the night sky with fresh eyes. Today, the tradition of stellar storytelling continues in innovative ways. Social media platforms like Instagram and TikTok have become stages for astronomers to share stunning images of nebulae, explain the life cycles of stars, or even live stream celestial events like solar eclipses and meteor showers. These bite-sized, visually rich stories make the cosmos feel tangible, inviting people who might never pick up a science textbook to engage with the wonders of the universe. But stellar storytelling isn't just about simplifying science, it's about creating emotional connections. When we learn about the birth of a star in a distant nebula or the explosive death of a supernova, we're not just absorbing facts, we're connecting to a narrative that spans billions of years. These stories remind us that the universe is not just a collection of objects, but a living, evolving entity with a history and a future. They invite us to see ourselves as part of something vast and interconnected, fostering a sense of awe and humility. One of the most impactful aspects of stellar storytelling is its ability to inspire the next generation of scientists and dreamers. When a child hears about the discovery of a new exoplanet or sees a breathtaking image of a galaxy, it can ignite a lifelong passion for exploration. Programs like NASA, Astronomy Picture of the Day, or public observatory events bring the cosmos to life, showing people of all ages that the universe is not just for experts, it's for everyone. And let's not forget the personal impact of these stories. For many, the stars are more than just distant lights. They are sources of comfort, inspiration, and reflection. Whether it's the quiet beauty of a starry night or the profound realization that we are made of stardust, the stories of the cosmos have a way of touching something deep within us. They remind us of our shared humanity, our curiosity, and our boundless capacity for wonder. As we reflect on the power of stellar storytelling, we're reminded that the universe is not just a place of discovery, it's a place of connection. By sharing its stories, we not only deepen our understanding of the cosmos, but also strengthen our connection to each other and to the world around us. And as we continue to explore the mysteries of the stars, we carry forward this legacy of wonder, inviting others to join us in the endless journey of discovery. This journey through the art of stellar storytelling brings us to the next chapter of our exploration, the role of stars in shaping our collective imagination and inspiring the dreams that drive us forward. From ancient myths to modern aspirations, the stars have always been more than just celestial objects. They are the keepers of our hopes, our fears, and our deepest questions about the universe and our place within it. Have you ever stood under a starry sky, overwhelmed by the sheer vastness of the cosmos? For many, that moment is transformative, a humbling reminder of how small we are, yet how deeply connected we feel to the universe. Stars have a way of touching us on a personal level, whether we're amateur stargazers with a backyard telescope or professional astronomers unraveling the secrets of distant galaxies. They inspire awe, spark curiosity, and sometimes even change the course of a life. Take, for example, the story of a young girl who first saw Saturn's rings through a telescope at a local star party. That single glimpse ignited a passion for astronomy that led her to become a planetary scientist, dedicating her career to studying the very worlds she once marveled at from afar. Or consider the amateur astronomer who, armed with little more than a homemade telescope and boundless enthusiasm, discovered a comet that now bears his name. These stories remind us that the stars don't just belong to scientists, they belong to anyone who's ever looked up and wondered. For professional astronomers, the connection to stars is both intellectual and deeply personal. Many describe their first encounter with a distant galaxy or a pulsar as a moment of profound clarity, a realization that they were part of something much larger than themselves. One astronomer recalls the first time she observed a supernova, describing it as watching the universe rewrite its own story in real time. That mix of scientific discovery and emotional resonance is what drives so many to spend countless hours peering through telescopes or analyzing data from distant stars. But the impact of stars isn't limited to those who study them. For poets, artists, and dreamers, the night sky is a source of endless inspiration. Vincent van Gogh's Starry Night captures the swirling beauty of the cosmos, while poets like Walt Whitman and Maya Angelou have used stars as metaphors for hope, guidance, and the eternal. Even in our modern, fast-paced world, the stars remain a universal symbol of wonder, a reminder to slow down and look up. This deep, personal connection to the stars is more than just a fleeting emotion. It's a legacy that spans generations. From the ancient astronomers who first mapped the constellations to the modern-day scientists unraveling the mysteries of black holes, each of us carries forward a piece of that shared human experience. It's a legacy that reminds us of our place in the cosmos, connecting us to the past, present, and future in ways that are both profound and deeply personal. As we reflect on the personal impact of stars, we're reminded that they are more than just celestial objects. They are mirrors reflecting our curiosity, our dreams, and our shared humanity. And as we turn our gaze to the next chapter of this journey, we'll explore how this legacy continues to shape not only individuals but entire cultures, weaving the story of the stars into the very fabric of our existence. The stars we see tonight are not just distant lights, they are storytellers, teachers, and architects of the cosmos. Their influence stretches far beyond their lifetimes, shaping the universe and inspiring humanity in ways that are both profound and enduring. From the elements they forge to the dreams they ignite, stars leave a legacy that transcends time and space, connecting us to the vast tapestry of existence in ways we're only beginning to understand. Consider the light of a star, traveling across millions of years to reach us. That beam of light, though ancient, carries with it the story of the star's life, its birth in a swirling nebula, its fiery existence, and its eventual death. Even after a star has faded, its light continues to illuminate the cosmos, a reminder of its presence and its role in the grand narrative of the universe. This light isn't just a relic of the past, it's a living connection, a bridge between the star's life and our own. The legacy of stars extends beyond their light. Every star is a cosmic alchemist, transforming simple elements like hydrogen and helium into the building blocks of planets, life, and even us. The iron in our blood, the calcium in our bones, and the oxygen we breathe were all forged in the hearts of stars and scattered across the universe by their explosive deaths. In this way, stars are not just distant objects, they are part of us, woven into the very fabric of our existence. But the impact of stars goes even deeper. They inspire us to dream, to explore, and to ask the big questions about our place in the cosmos. For centuries, stars have guided explorers, inspired artists, and sparked the imaginations of scientists. They are symbols of hope and possibility, reminding us that the universe is vast, mysterious, and full of wonder. Whether it's a child gazing at the Milky Way for the first time or an astronomer uncovering the secrets of a distant galaxy, stars have a way of touching us on a deeply personal level. This cosmic interconnectedness, the idea that we are all made of stardust and bound by the same physical laws, is one of the most beautiful and humbling truths of science. It reminds us that the universe is not just a collection of separate objects, but a single, interconnected whole. The life and death of stars, the formation of galaxies, and the evolution of life on Earth are all part of the same ongoing story, a story in which we play a small but meaningful role. As we continue to explore the cosmos, the legacy of stars serves as both a guide and an inspiration. They remind us of the beauty and complexity of the universe and of our shared connection to it. And as we look to the stars, we're reminded that their light is not just a glimpse into the past, it's a beacon for the future, illuminating the path forward in our endless journey of discovery. This reflection on the legacy of stars leads us to the next chapter of our exploration, the concept of cosmic interconnectedness, and how the universe, in all its vastness, is bound together by shared origins and shared stories. From the smallest particles to the largest galaxies, the cosmos is a single, unified tapestry, woven together by the light and life of stars. In the vast expanse of the universe, stars are far more than isolated points of light. They are threads in an intricate cosmic web, bound together by forces that shape the very fabric of existence. This web, woven by gravity, light, and the flow of energy, connects stars across unimaginable distances, creating a dynamic network that drives the evolution of the cosmos. From the smallest red dwarfs to the most massive supergiants, each star plays a role in this interconnected tapestry, influencing everything from the formation of galaxies to the distribution of life-giving elements. Gravity is the invisible force that holds this web together. Stars, galaxies, and even clusters of galaxies are linked by its pull, creating structures that span billions of light years. Picture a single star, its gravitational influence extending far beyond its own system, tugging on nearby stars and shaping their orbits. Over time, these interactions give rise to star clusters, galaxies, and even larger cosmic structures like filaments and voids. It's a delicate dance where the movements of one star ripple through the web, affecting countless others in ways that are both subtle and profound. Light, too, plays a crucial role in this interconnectedness. The light from a star doesn't just illuminate its immediate surroundings, it travels across the cosmos, carrying information about its composition, temperature, and age. When we observe a distant star, we're not just seeing a point of light, we're receiving a message from the past, a glimpse into the history of the universe. This light also interacts with the interstellar medium, ionizing gas and triggering the formation of new stars in a cycle that has repeated for billions of years. Energy, the lifeblood of stars, flows through this cosmic web in countless ways. Through nuclear fusion, stars convert hydrogen into helium, releasing energy that powers their brilliance and heats the surrounding space. When stars die, whether in quiet whimpers or explosive supernova, they release this energy back into the universe, enriching the cosmos with heavy elements and fueling the birth of new stars and planets. This cycle of creation and destruction, driven by the flow of energy, is the heartbeat of the universe, a rhythm that has shaped its evolution since the first stars ignited. The interconnectedness of stars extends even to the largest scales of the universe. Galaxies, each home to billions of stars, are themselves connected by vast filaments of dark matter and gas, forming a cosmic web that stretches across the void. Within this web, stars are not just passive participants, they are active agents, shaping their surroundings and influencing the formation of new structures. The light and energy they emit can trigger star formation in neighboring galaxies, while their gravitational pull can draw galaxies together, leading to collisions and mergers that reshape the cosmic landscape. As we reflect on this intricate web of stars, we're struck by the beauty and complexity of the cosmos. It's a universe where nothing exists in isolation, where every star, every galaxy, and every particle is part of a larger whole. This interconnectedness is not just a scientific concept, it's a reminder of our own place in the universe, a connection that binds us to the stars and to each other. This profound sense of connection leads us to the next chapter of our journey, the concept of cosmic evolution, and how the interactions between stars and galaxies have shaped the universe over billions of years. From the first flickers of starlight to the grand structures we see today, the story of the cosmos is one of constant change, growth, and renewal. And as we continue to explore, we uncover not just the secrets of the stars, but the story of how the universe itself came to be. As we journey through the lives of stars, their fiery births, their radiant prime, and their explosive ends, we're reminded of the sheer beauty and complexity of the universe. Each star, whether a humble red dwarf or a dazzling blue giant, is a masterpiece of cosmic artistry, a testament to the delicate balance of forces that shape existence. The intricate dance of gravity, fusion, and radiation that defines a star's life is not just a scientific process. It's a story of creation, resilience, and transformation that echoes across the cosmos. Take a moment to consider the night sky. What we see as a tapestry of twinkling lights is, in reality, a vast network of stellar lives at different stages. Some stars are just beginning their journey, glowing faintly in the depths of nebulae. Others are in their prime, burning brightly and warming planets that might harbor life. And some have already met their end, leaving behind remnants like nebulae, neutron stars, or black holes. This diversity, this grand mosaic of stellar existence, is what makes the universe so breathtakingly beautiful. But the beauty of the cosmos isn't just in its appearance, it sits in the intricate processes that sustain it. The fusion of hydrogen into helium, the creation of heavier elements in supernova, and the scattering of these elements to form new stars and planets are all part of a cycle that has repeated for billions of years. This cycle is not just a scientific phenomenon, it's a story of renewal, of how the universe continually reinvents itself, using the remnants of old stars to build new worlds. What's perhaps most awe-inspiring is how this complexity is woven into the very fabric of our lives. The atoms in our bodies, the oxygen we breathe, and the iron in our blood were all forged in the hearts of stars. We are quite literally made of stardust. This realization connects us to the cosmos in a deeply personal way, reminding us that we are not separate from the universe but an integral part of its story. The study of stars doesn't just deepen our understanding of the cosmos, it deepens our appreciation for it. Every time we look up at the night sky, we're not just seeing distant lights, we're witnessing the legacy of billions of years of cosmic evolution. We're seeing the echoes of the Big Bang, the birth of the first stars, and the creation of the elements that make life possible. It's a humbling reminder of how vast and interconnected the universe truly is. As we prepare to conclude this journey through the lives of stars, let's take a moment to reflect on what we've learned. Stars are more than just celestial objects. They are storytellers, teachers, and architects of the cosmos. They remind us of the beauty and complexity of the universe and of our place within it. And as we continue to explore their mysteries, we're reminded that the story of the stars is also the story of us, a story of creation, connection, and endless wonder. This celebration of the cosmos leads us to the final chapter of our exploration, a reflection on the profound impact that stars have had on humanity and how their light continues to guide us forward in our quest to understand the universe and our place within it. As we near the end of our journey through the Nebular Chronicles, it's worth taking a moment to reflect on the incredible story we've uncovered, a tale of creation, destruction, and the enduring legacy of stars. From the swirling clouds of stellar nurseries to the explosive brilliance of supernova, we've explored how stars are born, live, and die, leaving behind a universe forever changed by their light. This isn't just the story of distant celestial objects, it's the story of how the cosmos evolves, how it creates the building blocks of life, and how it inspires us to look beyond our world and dream of what lies beyond. One of the most profound takeaways from this journey is the realization that stars are not just isolated points of light, they are interconnected players in a vast cosmic drama. Their lives are governed by the delicate balance of gravity and fusion. Their deaths enrich the universe with the elements that make planets, and even us, possible. Every star, whether a tiny red dwarf or a colossal supergiant, contributes to the grand tapestry of the cosmos, weaving a story that stretches across billions of years. Understanding the birth and demise of stars isn't just about satisfying curiosity. It's about recognizing our place in the universe. The atoms in our bodies, the air we breathe, and the ground beneath our feet were all forged in the hearts of stars. This connection, this shared origin, reminds us that we are part of something much larger than ourselves. It's a humbling thought, but also an empowering one, as it invites us to see the universe not as a distant, unknowable void, but as a living, evolving entity to which we belong. The Nebular Chronicles have also shown us how stars shape the universe on the grandest scales. From the formation of galaxies to the distribution of dark matter, stars are at the heart of the cosmic processes that define the structure and evolution of the cosmos. They are the architects of the universe, sculpting its shape and seeding it with the ingredients for future stars, planets, and perhaps even life. But perhaps the most inspiring lesson of all is the reminder that the universe is a place of endless wonder and possibility. Every discovery we make about stars opens new questions, new mysteries to explore. From the first light of the Big Bang to the distant worlds we're only beginning to discover, the story of the cosmos is still being written. And as we continue to explore, we're reminded that the stars are not just distant lights, they are guides, lighting the way forward in our quest to understand the universe and our place within it. As we prepare to conclude this journey, let's carry forward the sense of awe and curiosity that the Nebular Chronicles have ignited. The stars have shown us that the universe is vast, complex, and beautiful, filled with stories waiting to be uncovered. And as we look to the future, we can only imagine what new wonders await us in the uncharted reaches of the cosmos. This reflection on the journey through the Nebular Chronicles brings us to the final chapter of our exploration, the lasting impact of stars on humanity and how their light continues to guide us forward. From the myths of ancient cultures to the cutting-edge science of today, the stars have always been more than just celestial objects. They are the keepers of our dreams, our hopes, and our endless quest for understanding. As we draw this journey to a close, let's take a moment to reflect on the profound impact stars have had not just on the universe, but on us. These celestial giants, born from chaos and destined to shape the cosmos, are more than just distant lights. They are the architects of existence, the storytellers of time, and the keepers of our deepest questions. From the fiery birth of the first stars to the remnants they leave behind, the story of stars is a tale of creation, connection, and the endless pursuit of understanding. Stars remind us of the beauty and complexity of the universe. They are not static objects but dynamic forces, constantly evolving and reshaping the cosmos around them. Their light, traveling across unimaginable distances, connects us to the past, offering glimpses into the universe's infancy and the processes that have shaped it over billions of years. And as we gaze at the night sky, we're not just observers, we're participants in this grand cosmic story, made of the very elements stars have forged. But the wonder of stars doesn't end with their light. They inspire us to dream, to explore, and to ask the big questions: what lies beyond our world? Are we alone in the universe? How did it all begin? These are the questions that drive astronomers, scientists, and dreamers alike, pushing the boundaries of what we know and challenging us to imagine what might be possible. The stars are not just distant points of light, they are beacons of curiosity, lighting the way forward in our quest to understand the cosmos and our place within it. As we conclude this exploration, let's carry forward the sense of awe and wonder that stars inspire. Whether you're an avid stargazer, a curious learner, or someone who's just beginning to look up at the night sky, the universe has endless stories to share. Each star, each galaxy, each cosmic event is a chapter in a narrative that's still being written, a story that invites us all to be part of the journey. So, the next time you step outside and look up at the stars, remember that you're not just seeing distant lights, you're witnessing the legacy of billions of years of cosmic evolution. You're connecting with the universe in a way that's both deeply personal and profoundly universal. And as you continue to explore, whether through a telescope, a book, or simply your own curiosity, you're adding your own chapter to the story of the cosmos. If this journey through the Nebular Chronicles has sparked your curiosity, I encourage you to keep exploring, dive deeper into the mysteries of the universe, share your discoveries with others, and never stop asking questions. The stars are out there, waiting to inspire you, challenge you, and remind you of the endless possibilities that lie beyond our world. Thank you for joining me on this incredible journey through the lives of stars. If you've enjoyed this exploration, don't forget to like, subscribe, and hit the notification bell so you never miss an adventure into the cosmos. Together, let's continue to uncover the wonders of the universe and celebrate the enduring legacy of the stars. Until next time, keep looking up because the universe has so much more to show us. As we reach the end of our journey through 42 Nebular Chronicles, the birth and demise of stars in a dynamic universe, I want to take a moment to thank you for joining me on this incredible exploration of the cosmos. Together, we've traveled through the fiery hearts of stellar nurseries, witnessed the explosive brilliance of supernova, and marveled at the remnants that stars leave behind, remnants that shape the very fabric of the universe. It's been a journey of awe, curiosity, and discovery, and I hope it's left you as inspired as it has me. Throughout this series, we've uncovered the profound interconnectedness of stars and the universe. From the creation of elements in their cores to the gravitational dance that binds galaxies together, stars are more than just celestial objects. They are the architects of existence. Their light carries the stories of billions of years, connecting us to the past, present, and future of the cosmos. And as we've seen, their legacy isn't just written in the stars above, it's written in the atoms that make up our world and even within us. But this isn't just a story about stars, it's a story about us. It's a reminder that curiosity and exploration are at the heart of what it means to be human. Every discovery we make about the universe deepens our understanding of where we came from and where we might be going. It's a journey that doesn't end here. It's one that continues every time we look up at the night sky with wonder and ask, what else is out there? Before we wrap up, I'd love to hear your thoughts. What part of this journey resonated with you the most? Was it the birth of stars in distant nebulae, the dramatic end of a supernova, or perhaps the idea that we're all made of stardust? Share your reflections in the comments below. I can't wait to hear what sparked your curiosity. And if you've enjoyed this cosmic adventure, don't forget to subscribe for more explorations into the mysteries of the universe. There's so much more to discover, and I'd love for you to be part of the journey. As we close this chapter, I'll leave you with a thought from Carl Sagan. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. So, the next time you step outside and gaze at the stars, remember that you're not just looking at distant lights. You're connecting with the story of creation itself. Keep looking up, keep asking questions, and keep that sense of wonder alive. Thank you for being part of this journey. Until next time, stay curious and may the stars always light